Why here current splits? Because it is a joint with the physical contact. So current is getting split. Here the current remains the same. Why? There is no physical contact. The total incoming current I splits into two, I1 and I2. So instead of I should write V by R. Instead of I1 I should write V by R1. Plus instead of I2 I should write V by R2. What we are doing? Bulb, toaster and a water filter. Resistance values are given. We have found out the total resistance, and the total resistance is what? 31.25. So electric torque is given that electric ion is having the same resistance. Now current I equal to what is the formula? V by R. V is what? 9 volt by resistance is what? 13.4 ohm. If you solve that, your answer will be 0.67 ampere. So hi students, we are starting 10th CBSE physics class today, and our first chapter that we are going to take is current, electricity, or you can simply say electricity. So first of all, what is the chapter name? Electricity. First of all, we should know what is electric current. Flow of electric charge through a conductor. What is current? Current is the flow of charges. Current is the flow of charges. Or you can say current is the rate of flow of charges. So what is current? Charge by time. What is current? Charge by time. Charge is denoted by letter Q and time is denoted by letter T. So current I equal to what? Current is denoted by letter I. So current I equal to what? Q by T. So what is Q? Charge. What is T? Time. Now remember, unit of charge is coulomb. Unit of charge is coulomb. Coulomb. Don't pronounce it as coulomb. It should be coulomb. Unit of charge is coulomb. Unit of current is ampere. Unit of current is ampere. Unit of time is what? Second. Unit of time, second. Now, there is an added point here. Total charge. Actually, the topic is law of quantization of charge. Actually, this is the name for this law, but this law is not given in your textbook. This heading is not given, but the equation is given Q equal to NE. So what is total charge of a body? It is the number of electrons in that body into charge of an electron. There are two types of charges. Two types of charges. Positive and negative. Positive charge, that is proton. Negative charge, electron. What is proton charge? Proton charge is equal to 1.6 into 10 raised to minus 19 coulomb. 1.6. Electron charge is what? Minus 1.6 into 10 raised to minus 19 coulomb. So electron is having negative charge, proton is having positive charge. Now some students might be having confusion between electron, proton and everything. Electron. So we used to write an element as XZA. What is Z? Atomic number. What is atomic number? Number of protons. What is atomic number? Number of protons. What is A? Mass number. Mass number also called as or number of nucleons. See, although this belongs to chemistry, you should have some idea. I am just making sure that you know the atomic structure. Number of nucleons. What are number of nucleons? Number of protons plus number of neutrons. So what are nucleons? Particles inside nucleus, particles inside nucleus are called nucleons. So when we write an element, what is X element name? What is A at mass number or number of nucleons? What are nucleons? Particles inside a nucleus. Okay, let's draw the figure of atomic structure. This is atom. At the center of atom, what we have? Nucleus. At the center of atom, what we have? Nucleus. Particles inside a nucleus. Particles inside a nucleus are called nucleons. What are they? What are nucleons? Protons and neutrons. Electrons are not inside the nucleus. Electrons are revolving around the nucleus. It is not inside the nucleus. Inside the nucleus, we have protons and neutrons. So A is mass number, Z is atomic number. Okay. Okay. So, and you also remember what is A minus Z? Mass number minus atomic number. What is mass number? Number of protons plus number of neutrons. That minus atomic number is what? Number of protons. So what we will get? Proton gets cancelled. A minus Z is equal to number of neutrons. So students, so what is A minus Z? Mass number minus atomic number? Number of neutrons. What is A? Mass number. What is Z? Atomic number. What is mass number? Number of protons plus number of neutrons. What is atomic number? Number of protons. So what is A minus Z? Number of neutrons. Now coming back law of condensation charge. Total charge of a body is what? Number of Q is what? Charge of a body. N is what? Number of electrons. Electrons or protons. Negatively charged means it is having electron. Positively charged means it is having proton. E is what? 1.6 into 10 raised to minus 19 coulomb. What is this? Proton charge. If it is negative, minus 1.6 into 10 raised to minus 19 coulomb. Why this is important? Because you can expect a question. How many electrons are there? How many electrons are there in 1 coulomb? See, Q equal to plus or minus Ne. So N equal to what? Q by E. Here Q is what? Charge. What is the charge? 1 coulomb. So 1 coulomb. Coulomb is represented by C. And E is what? 1.6 into 10 raised to minus 19. So how many electrons are there? N equal to 1 by, instead of charge I am writing 1 coulomb, divided by 1.6 into 10 raised to minus 19. So 1 by 1.6 into 10 raised to plus 19. Now what is 1 by 1.6? It is 0.625 into 10 raised to 19. So what is N? 6.25 into 10 raised to 19. This is the number of electrons. How many electrons are there or how many protons are there? 6.25. See, it is a number. So number number of electrons should be positive. So that is the reason why I have not given minus sign. Okay, number, how many apples are there? It cannot be negative, right? So how many electrons are there? So we got a positive. It is 6.25 into 0.625 into 10 raised to 9, 6.25 into 10 raised to 18. It is better to by heart 1 by 1.6 as 0.625. It will be helpful for 10th and also plus 1 plus 2 and also for entrance if you are planning for entrance. It will be helpful for you if you remember this fraction. So coming to our next point, when we write an element, for example, 56 Fe 92, what does it mean? 56 is what? Number of protons. That is atomic number. Z. What is 92? Mass number. Which is what? A, mass number, or number of nucleons. What is the number of protons? 56. Now, what is the number of neutrons? Number of neutrons, how to find out that? We have seen it is mass number minus atomic number. So 96 minus 56. What is, sorry, 92 minus 56. So what is answer? 66, 76, 86, then what? 92. So 36 is the number of neutrons. The denominator one is what? Z. What is Z? Number of protons. So how many protons are there? 56. How many neutrons are there? 92 minus 56 is equal to what? 36. So remember, Q equal to Ne. Total charge Q equal to Ne. Please remember that. Where Q is the total charge of a body, N number of electrons or protons, E is what? Charge of an electron or proton. Now coming back to our first slide, we were seeing current. What is current? Is the rate of charge flow. Current is the current equal to charge by time. I equal to Q by D. Now we know that instead of Q I can write Ne. So what is current? Ne by T. So we got the equation current as what? Ne by T. Because instead of Q we can write Ne. I hope it is clear. Next, flow of electric charge through a conductor. Conventionally, direction of current is taken opposite to the direction of flow of electrons, which is very important. If electron flow is in this direction, then current flow will be in the opposite direction. Current flow, suppose electron flow is towards the right side, then current flow will be opposite to that. So current flow will be towards the left side. What is the unit of current? Ampere. What is 1 ampere? What is 1 ampere? Current I equal to Q by T. When we say current as 1 ampere, when Q equal to 1 coulomb, time equal to 1 second, then we will get current as 1 ampere. When we say 1 ampere current is flowing, when 1 coulomb charge flows for a time interval of 1 second, we say that current is said to be 1 ampere. Current is said to be 1 ampere. 1 ampere when 1 coulomb of charge, flows for 1 second. When 1 coulomb of charge flows for 1 second, we say that current to be 1 ampere. 1 coulomb charge flows for a time of 1 second, we say that current is 1 ampere. Okay, that is the actual definition of current. So some students will be saying, sir, if 100 coulomb charge is flowing for 100 second, then also current is 1 ampere. Right only. You can define it in different ways. We are following the NCERT definition. Okay, my current is we use ammeter to measure current. The instrument which is used to measure current is ammeter. In the figure, this is cell. Remember, I can give you examples. The cell is denoted by this is the symbol of a cell. Positive, negative. This is the symbol of ammeter. This is the symbol of ammeter. Okay. Now, okay. Next, this is the symbol of switch. If there is a dot sign, closed switch. If dot sign is not there, then it is an open switch. When switch is open, no current flows. When the switch is closed, current flows. This is stand for ammeter. This is the symbol of a cell. Now, but we used to call battery if there is more than one cell. This is one cell, this is second cell. We call it as battery. Battery is a group of cells. Group of cells is called battery. Group of cells is called battery. So that is also done. Now, this is the schematic diagram of an electric circuit comprising cell, electric bulb, ammeter and a plug key, that is switch, plug key. When the switch is inserted or when the key is pressed, current flows. This is the bulb. This is bulb. This is ammeter. This is switch or plug key. Switch or plug key. I hope it is clear. Now, there is a direction of current. I is shown like this because current flows in this direction. Current flows from positive terminal of the cell to the negative terminal of the cell. So, the circuit is complete. So, we can say that circuit is complete. Now, remember, if there is a gap in the circuit, now, will there be any current flow? No, because current always flows in closed circuit. Remember, current always flows in closed circuit. Current always flows in closed circuit. Current always flows in closed circuit. Now, will there be current flow? No, because there is an open section. So, I am removing that. I am making it closed. Current always flows in closed circuit. Always remember current flows in closed circuit only. Now, it became closed. There will be current flow. So, this page is done. Here we are seeing what is Q equal to NE equation, current I equal to rate of charge flow, current I equal to Q by T. What is Q? NE. So, current I equal to NE by T. So, unit of current is ampere, unit of charge is coulomb, unit of time is second. Now, remember, I hope you know that, but still I am telling you, 1 minute is equal to 60 seconds. 1 minute equal to 60 seconds. 1 hour is equal to 60 minutes. That is equal to 60 into 60. That is 3600 seconds. Because we require this data for doing problems. 1 year is equal to what? 365 days. So, how many seconds are there in 1 year? 365 days. 1 day 24 hours into 1 hour 60 minutes into 1 minute 60 seconds. If you multiply, if you do this multiplication, then you will get 1 year in seconds. Okay, these data are very important. 1 minute 60 seconds, 1 hour 60 minutes, that is 3600 seconds. Now, what is 1 day? 1 day is equal to 24 into 24 hours into 1 hour is 60 minutes into 60 seconds. If you do this calculation, you will get the answer. So you have to note down this, because this data is very important. So when you do that calculation, so one day is equal to how much hours? 86,400. 1 day is 24 hours. How much seconds? 86,400 seconds. This will be useful information because it will be it is required while doing problems. So please by heart these values. Okay. Now let's see. So we are done with this page. Then this data we have seen. Cell we have familiarized with the different electrical components. Then I equal to Q by T. Then law of condensation of charge. Actually, this law is called law of condensation charge, but it is not there in your textbook. But this equation is given in problems. In theory side, you can't see this equation, but in problems, our NCERT textbook follows this equation. So we have to by heart this equation. Q equal to Ne. N is number of electrons. E is what? Charge of an electron. Then how many electrons are there in 1 coulomb? That problem is done, and we know that when we say an element, when we see an element, what we have said is what? Atomic number of protons. A is what? Mass number of nucleons. What is A minus Z? Number of neutrons. So that we have seen atomic structure also we have seen. Next, symbols of some commonly used components in circuit diagram. Electrical cell we have seen. Then a battery or a combination of cells, that is also seen. Plug key or switch, open, closed, that is done. Wire joint, this is a wire joint. Here current can be, if current is coming in this direction, it can flow both the wires. Here what happens? Current is jumping, it is not in contact with the middle wire, horizontal wire. Wire crossing without physical contact. Okay, so if this is I1, this current will be I2. Both current will be different because there is no physical contact. So we call it as crossing without joining. Here current is what? Current is getting split. Suppose this current is I, it is getting split. Now what happens? Is there any physical contact? If the incoming current is I, this will be I1 and this will be I2 here. Now here I2, I1 both will remain different. Why? Because there is no physical connection. Why here current splits? Because it is a joint with physical contact. So current is getting split. Here the current remains the same. Why? There is no physical contact. Wire crossing without joining. Here it is called wire joint. I hope it is clear. Current is getting split here. Here there is no change in current because there is no physical contact. Electric bulb we have seen. Now resistor. Now before seeing resistor, we should know what is Ohm's law. Before seeing resistor, we should know Ohm's law. What is Ohm's law? Ohm's law. Very important Ohm's law. First of all, I should write the statement. At a constant temperature, current flowing through a wire, is through a wire, it's better to write conductor, through a conductor is directly proportional to the potential difference applied across the conductor. applied across the conductor. Now, what is potential difference? See, suppose there are two buckets connected with each other. So, I am making a connection here. So, what happens? Initially, this bucket was having this much water. The second one was empty. When it is connected, what happens? The water flows from this bucket A to bucket B. Up to what point there will be water flow? Up to what point there will be water flow? Till their levels are equal. Till their levels are equal. From A to B, there will be water flow. Till their levels are equal. Let it be this point. Till their water levels becomes what? Equal. There will be current flow. Okay. There will be water flow. So, whenever there is a difference in level, there will be flow. Now, why you are listening to my class? Because the knowledge level or my knowledge level in physics is higher than you in 10th standard. So, what I am trying to do, I am trying to increase your knowledge level up to my level. So, whenever there is a level difference, there will be flow. Okay, as a teacher, I won't prefer students for combined study. Why? When you go for combined study, your knowledge level and your friend knowledge level both are same. So, I don't think there will be much knowledge transfer between you. But if you are going to a teacher, the teacher knowledge level is high. So, teacher makes sure that students is up to the same level of the teacher once the academic year is completed. So, what is Ohm's law? If there is a difference in level, there will be flow. If there is a difference in knowledge level, there will be knowledge flow. If there is a difference in water level, there will be water flow. If there is a difference in potential level, there will be current flow. Suppose these are two bodies. This one is having lot of charge. This one is uncharged body. So when you connect them, what happens? The charge flows from first body to second body till their potentials are equal or till their charges are equal. Till their charges are equal. Up to that moment, there will be flow. So suppose this one is having 100 coulomb, this one is 0, and suppose the second body, this is A, this is B, and another C is connected to B. First one is having 100 coulomb charge and the second one is having 200 coulomb charge. Which will have more current flow? The second one, because second one is having more charge. That means the more the charge, more will be the potential. So more will be the current flow. So some students might be wondering why we are having cell in a circuit. Why we are having a cell in a circuit? The positive terminal of the cell, switch is closed. The positive terminal of the cell is having lot of charge. So the more the charge, more will be the potential. Negative side is having low amount of charge. So low potential. So there is potential difference. So due to this potential difference, current flows from positive terminal to the negative terminal. Now during that flow, it meets bulb. So bulb glows. So what is the role of a cell in a circuit? It's a very wonderful point. The role of a cell is to provide potential difference. What is the role of a cell? To provide potential difference. The cell provides potential difference. When there is potential difference, there will be current flow. You have seen remote battery. Remote batteries are what? Two cells. Two 1.5 volt cell. 1.5, 1.5. When they are connected, what will be the total potential? 1.5 volt. Potential difference unit is volt. Now, according to Ohm's law, V directly proportion to I, potential difference directly proportion to current, V equal to IR. What is this V? Potential difference. Potential difference. Unit V. Unit volt represented by V. Now, what is R? R is the resistance. Resistance. Resistance is the hindrance. Hindrance means blockage. Hindrance offered to the flow of electric current. Hindrance offered to the flow of electric current. Suppose you are going in a straight highway. When you see this, you have to slow down. What is this thing in your highway or road? Hump. When hum comes, we slow down. Similarly, electrical resistance is the hindrance or blockage offered to the flow of electric current. It is denoted by R. Unit of resistance is ohm. Unit of resistance is ohm. It is in the name of George Simon Ohm. Scientist name, we use the symbol ohm. So what is the resistance? It is the hindrance, blockage offered to the flow of electric current. So what is Ohm's law? V is equal to IR. Now coming back to the previous section, when the remote battery is connected 1.5 volt and 1.5 volt, what is the total voltage? 3 volt. So there is a potential difference of 3 volt. So what happens? The current flows through the remote circuit. There will be battery. From that battery, current flows through the circuit. Okay. Now, after using the remote for a long period, what happens? The potential reduces. Why? Because there is not enough charges. So, potential difference will be less. So, current also will be less. So, what happens? After some time, the remote battery gets exhausted. It is not having enough charge. So, what is current? Rate of charge flow. If there is no enough charge, there will be not enough potential difference. So, what? Current will be zero and remote battery will not be working. So what we will do? We will tell our parents, please change the remote battery. So again, when you put new battery, again potential difference increases, again current increases. Now suppose this battery is 1.5 volt. When the battery is used for longer period of time, there will not be charge difference between positive and negative terminal. So will there be any current flow? No. Because the Ohm's law tells you it is the potential difference that creates the current, not potential. If suppose your body is having too much charge or too much potential, will there be current flow? No. Why it is important? Because I told my daughter, be careful while dealing with the electrical current. There are two wires, phase and neutral, to your home. Phase is 230 volt and neutral is 0 volt. Some students might be wondering, sir, why there is neutral? While I was studying 8th standard, I asked my physics sir, why we require a neutral? Because neutral means no voltage. We are not getting shock from electrical shock from neutral. Then why neutral is required? Because neutral is required because it is the neutral which provides potential difference. Simply having potential current won't be there. Suppose Listen, suppose I got 98% in my SSLC, CBSE 10th standard exam. Everybody started congratulating me. Lindo, my name is Lindo. Yeah, Lindo, you got a very good mark. Why? Because other student didn't get enough mark. Suppose all got 98 mark. Will I get any appreciation? No. So it is the potential difference that creates the current. The potential difference is important. Okay, we will get a congratulation from everywhere if we score high, if there is a level difference between students and we are at the top side, then only there will be current flow. That difference is very important for the current to flow or any flow. Water level difference is important for the water to flow. Knowledge level difference is important for the knowledge transfer from teacher to student. If teacher is having only that much information of student, will there be any knowledge transfer? No. Will there be any knowledge flow? No. So, two wires are there to our home, 230 volt and 0 volt. One is phase and the other one is neutral. What is the role of neutral? To provide potential difference. Suppose a crow sits on the phase wire like this. Will it get shock? No. Why? Because one leg, this is crow. I hope you can imagine it as crow. One leg of the crow is at 230 volt. Other leg is also at 230 volt. So what is the difference in potential? 0. Crow won't get shock. Suppose another crow sits like this. What will happen to it? It will get fried because one leg is at 230 volt and other leg is at 0 volt. So what is the difference in potential? 230. So large current flows. Large current flows. So it's very important to understand Ohm's law. So what is Ohm's law? V directly proportion to I. V is equal to IR. So I equal to what? V by R. R equal to what? V by I. R equal to what? V by I. Any doubt? I hope it is clear. I hope it is clear. R equal to V by unit of R, ohm, unit of current, ampere, unit of potential difference, volt. Please don't forget all these things. Okay. Ammeter, yeah. Voltmeter is a device used to measure voltage. Ammeter is a device used to measure current. Now we have seen resistor. What is variable resistor? Variable resistor is also called rheostat. There are two symbols. It can be either this symbol, variable resistor, or you can use this symbol, rheostat, for variable. Variable resistor means you can alter the resistor value. That is variable resistor or rheostat. These symbols are important. You can expect question. Ohm's law, we have seen Ohm's law. Crow case we have done. Resistance we have done. Yeah, this is the graph of Ohm's law. See, we have drawn a graph with the current on the x-axis and the potential difference on the y-axis. See, potential difference, unit is volt on the y-axis and current is on the x-axis. Figure 11.3, VI graph of for a nichrome wire. A straight line plot shows that as the current throughout the wire increases, the potential difference across the wire increases linearly. This is Ohm's law. What is linearly? When one quantity increases, other quantity also increases. We call directly proportional or linear graph. This is a linear graph. When current increases, voltage also increases. Or you can say when voltage increases, current also increases. See, point 1. Current is what? Current is 0.1 when the voltage is what? 0.2. When voltage becomes 0.3, current is what? 0.2. It goes on like that. At when current is 0.3, voltage is what? 0.8. Okay, it goes on like that. So when potential difference increases, current also increases. I can draw a simple diagram. See, this is 1, 2, 3, 4. This is 1, 2, 3, 4. Let's see. See, for 1 ampere current, 1 volt, 1 ampere current, 2 volt, 2 ampere current, 3 volt, 3 ampere current, 4 volt, 4 ampere current. I hope it is clear. It's a linear graph. When one quantity increases, other quantity also increases. So you can expect a question from this diagram. What will be the resistance of this graph, of this circuit? Now I am thinking, what is the resistance? I know that V directly proportional to I. V is equal to what? IR. R equal to what? V by I. So if you divide voltage by current, we will get the resistance. What is the voltage? For example, I am taking this as my reference. So what is the voltage? 4 volt. What is the corresponding current? What is the corresponding current? 4 ampere. 4 volt by 4 ampere. What is the resistance? 1 ohm. Any doubt? Voltage by current is what? Resistance. Any doubt? I hope it is clear. I hope it is clear. Okay, next year. What is electrical circuit? It is a continuous and closed path of electric current. See, this closed path is very important. Current will flow in a circuit only if it is closed. Okay, you can expect a question. There is a bulb, there is a cell, there is a switch, and an ammeter is there. Will there be any current flow in this circuit? No. Why? It is an open switch. No current flow. Now I am putting the key. Now it is a closed circuit, so there will be current flow. Current flows only in the closed circuit. Components, battery, cell, conducting wires, load. Load means this bulb or resistor. Load can be bulb or resistor, etc. Now, electrical potential and potential difference. Work done to move a unit charge from one point to another is called electrical potential. What is potential? What is potential? It is the work done. Suppose there is a point A, suppose there is another point B. What is potential? It is the work done to move a unit positive charge from one point to another. Suppose I am moving +1 coulomb charge from point A to point B. How much work is done by me? That is the potential. So, potential difference is equal to what? Potential difference between 2 points is the, between 2 points is the work done to move a charge, to move what charge? Move a unit positive charge, from one point to another. So what is the equation for potential? Potential is equal to work done by charge. Potential is equal to work done by charge. What is the unit of work done? Joule. What is the unit of charge? Coulomb. So what is the unit of potential? Joule per coulomb or volt. What is the unit of potential? Joule per coulomb or volt. Measured using voltmeter. Remember, an ammeter, very important 2 points I am writing. Ammeter always connected in series. Connected in series with the low resistance. Low resistance. Why? Suppose there is a bulb. Bulb is there. Then there is a cell. Then there is a switch. Okay. I have to measure, this is a bulb. I have to measure the current through this circuit. In order to measure current, I should use what? Ammeter. See, I am placing an ammeter here. I am placing an ammeter here. Now, ammeter will have small resistance. Every device will have small resistance. Now, suppose somebody asks me, sir, what should be the resistance value of the ammeter? It should be high or low? I am thinking, when a circuit is connected like this, if the ammeter resistance is very high, what happens? I am remembering the definition of resistance. It is the hindrance or blockage to the flow of electric current. If I am using an ammeter of high resistance, will there be current flow? No. So, ammeter always connected in series with the low resistance. Ammeter should be having very small value of resistor. Then only there will be smooth current flow. Okay. And a voltmeter, next point. A voltmeter always connected in parallel. Always connected in parallel with high resistance. Why it is so? Because suppose there is a bulb and there is a cell and there is a switch, and the switch is closed, there will be current flow. Voltmeter is always connected in parallel. If the connection is like this, we call it as parallel connection. Why voltmeter resistance should be high? If voltmeter resistance is low, suppose voltmeter resistance is low, what is the problem? Suppose current is flowing, current is reaching this junction. Now, in order to get to the other side of the circuit, current is having two paths. One is through the bulb and other through the voltmeter. If voltmeter resistance is low, what will be the problem? Then the current always prefer what? The lesser resistance path. Now, when you are seeing two roads, one road is having full of block and the other road is a plain road, no traffic. What you will prefer? The second one, right? Obviously, the current also prefer the path through the voltmeter. So, what is the problem? Bulb will not glow. Actually, what was your purpose? To know the potential difference across the bulb. For that purpose, we are connecting voltmeter. If your voltmeter resistance is low, what is the problem? Bulb will not glow. So, you have to make sure that your voltmeter is having very high resistance. What is the advantage now? When now current is seeing two paths. The path through the voltmeter is having very high resistance. So, will the current flow through that path? No. Current will flow through the bulb. So, bulb will glow brightly. If voltmeter resistance was low, what was the problem? All the current will flow through the voltmeter. So, bulb won't glow. So, in order to find out the potential difference of a bulb across the bulb, you should use a voltmeter. That is one point. The voltmeter should be connected in parallel. That is another point. And the resistance of the voltmeter should be very high. I hope it is clear. Continuing. Ohm's law we explained. Resistance is the property that opposes the flow of electric current. The potential difference across the ends of a conductor is directly proportional to current flowing through it, provided temperature remains constant. For Ohm's law to be valid, temperature should be a constant. V directly proportional to I, V equal to IR. R is the resistance, unit is Ohm. R is what? Resistance. What is resistance? It is the blockage offered to the flow of electric current. Opposition offered by conductor to the flow of electric current is called resistance. SI unit to Ohm. 1 ohm is equal to 1 volt per 1 ampere because resistance R equal to V by I. So 1 ohm is equal to what? 1 volt divided by 1 ampere. Now, factors affecting length, resistance. Remember, resistance directly proportional to length. So, length of the when the length of the conductor increases, resistance also increases. Resistance directly proportional to 1 by cross-sectional area. That is very important. See, if I draw a wire like this, generally we take whole area. No, that is not the case here. We should take only cross-sectional area. This is the cross-sectional area, not the total area. A is what? Cross-sectional area. Please do remember that. A is what? Cross-sectional area. Then when you combine these two equations, you will get R directly proportional to length. That means when length increases, resistance also increases. Length decreases, resistance also decreases. R inversely proportional to cross-sectional area. What is inversely proportional? When one quantity increases, other quantity decreases. When cross-sectional area increases, resistance decreases. R directly proportional to L by A. R is equal to rho L by A. When you remove the proportionality, there should be a constant. This constant is called resistivity. What is this constant? Resistivity. Another name, specific resistance. What is other name? Specific resistance. Resistivity or specific resistance. Again I am writing resistance directly proportional to length, resistance directly proportional to 1 by cross-sectional area, resistance directly proportional to L by A. We are combining these two equations. R equal to what? Rho L by A. How it is pronounced? Rho. Rho. What is rho? Rho is called resistivity. Now, rho R equal to what is the formula? Rho L by A. So, what is rho? RA by L. What will be the unit? R is what? Ohm. Area is what? Meter square. Length is what? Meter. So, meter gone. So, what is resistivity? Ohm meter. What is resistivity? Ohm. What is the unit of resistivity? Ohm meter. Resistance unit ohm, area unit meter square, length unit meter. So when you cancel 1 meter, you get unit of resistivity. Unit of resistivity is what? Unit of resistivity is what? Is ohm meter. Unit of resistivity is ohm meter. Now, why it is called specific resistance? See, rho equal to RA by L. How we are getting R equal to rho L by A? We are placing rho there. We are moving A to the right side, left side, and bringing L to the denominator. So, rho equal to RA by L. Now, if A equal to cross-sectional area equal to 1 meter square, length equal to 1 meter, then rho equal to what? R. So, if you are specifying cross-sectional area as 1 meter, if you are specifying length equal to 1 meter, if we are specifying cross-sectional area as 1 meter square and the length equal to 1 meter, what you got? Resistivity equal to resistance. If wire is having unit cross-sectional area and the unit length, then that wire resistance will be equal to resistivity. So that is the reason why rho is also called specific resistance. Why specific resistance? If wire is having unit length and unit cross-sectional area, resistance will be equal to resistivity. I am noting that point here. If a wire is having unit length and unit cross-sectional area, unit cross sectional area if a wire is having unit length and unit cross sectional area, its resistance will be equal to resistivity. Will be equal to resistivity. Will be equal to resistivity. Unit length, if a wire is having unit length and unit cross sectional area, both resistance and resistivity will be equal. So we are specifying it should be unit length, it should be unit cross sectional area. Then resistance will be equal to resistivity. So that is the reason why it is also called specific resistance. We are particular about unit cross sectional area and unit length. Resistance of a conductor of unit length and a unit cross sectional area SI unit ohm meter depends on the nature of the material, not on its dimensions. It's very important. When you increase, up arrow means increasing length or decreasing length, increasing cross sectional area or decreasing cross sectional area, rho remains constant, resistivity remains constant. Even the length is increased or decreased, even the cross sectional area increased or decreased, resistivity rho remains constant. So you can expect a question. A resistance wire is having 100 ohm resistance. If it is stretched 10 times, what will be the new resistivity? Will there be any change in resistivity? No. Resistivity is a constant. It does not depend on length or cross sectional area. Good conductors, metals and alloys are having what? Low value of resistivity. And insulators are having what? High value. Conductors 10 raised to minus 8, 10 raised to minus 6. So resistivity will be very low for conductors and very high for insulators. Insulators 10 raised to 12, rubber glass. Insulators means what? Which substances which does not conduct electricity. It is having 10 raised to 12, 10 raised to 17 ohm meter. That is huge resistivity for insulators. And very small, 10 raised to minus 8, 10 raised to minus 6 ohm meter for conductors. So conductors having low value for resistivity, insulators are having high value of resistivity. Resistivity also called specific resistance. Its unit is ohm meter. So even we increase or decrease length, even we increase or decrease cross sectional area, resistivity resistivity does not change. Resistivity is independent, depends on what? Nature of the material, not on its dimension. Why nature on material? If you are adding copper to gold wire, its resistivity will change. If you are adding copper to silver or silver to copper, then resistivity will change. But if you take a single copper wire and if you stretch it or compress it, still its resistivity won't change. Resistivity does not depend on length, size, shape of the conductor. It depends only nature of the conductor. If you are adding copper to a silver wire, its nature changes. If you are adding silver to a gold wire, its nature changes. So resistivity also changes. So, but by changing dimensions, you cannot change resistivity. Okay. So students, continuing with the electricity, today we are going to see combination of resistors. How resistors can be connected in different ways. So there are two ways of resistor connection. Resistor combination. It is of two types. First one, series, and the other one parallel. Resistors can be connected in series and in parallel. In series combination, Let's take an example of two resistors connected in series back to back. So this is first resistor, this is cell, and we are having a switch. Switch is closed. So this is resistor with resistance R1, R2, current is flowing. So first of all, how many paths are there in this circuit? Only one path. If you are seeing only one path in an electrical circuit, you should understand that it is a series combination. So what is the specialty of series combination? Current will be same. Current will be same throughout. Current will be same throughout the circuit. Throughout the circuit. Now, this is the supply potential V. We know that potential difference unit is volt represented by V. So, current is flowing. Here, one end of a resistor R1 is connected to positive terminal. Other end of resistance R1 is connected to second resistor R2. So, you should understand that from the total supply potential, R1 resistor uses, let it uses V1 volt. Then R2 resistor uses how much volt? V2 volt. See, when current passes through an electrical circuit, you should understand that whenever current sees resistor, there will be voltage consumption. There will be voltage consumption. So what is the voltage consumed by first resistor? V1. Again the same current flows through the second resistor. So what is the voltage consumed by second resistor? V2. Why this two voltage is different from supply voltage? Because it is a series combination. Current will be same throughout the circuit. Voltage will be different across resistors. Different across resistor. So in series combination, what is the speciality? Current same. In series combination, what is the speciality? What is the point to remember? Current same, voltage different. Very, very important point. Voltage will be different. So what is the supply voltage? Supply voltage is V. Out of the supply voltage, some voltage is consumed by resistor R1, that is V1. Some voltage is consumed by resistor R2, that is V2. Now, V directly proportion to I, V is equal to IR. So, instead of V, I should write IR. Now, instead of V1, I should not be writing I1 R1. Why? Because current is same. That is the reason why I am not writing I1 R1. I am writing IR1. Across the second resistor, what is the voltage? IR2. Now, IR is equal to I into R1 plus R2. Now, what happens? You can cancel I. So, R is equal to what? R1 plus R2. This is the formula for equivalent resistance, that is total resistance when resistors are connected in series. So R series is equal to what? R1 plus R2. So what you are understanding? When resistors are connected in series, total resistance increases. When resistors are connected in series, total resistance increases. Total resistance increases. Total resistance increases. Now, suppose example, there is a 5 ohm resistor, another 5 ohm resistor connected in series. Plus minus voltage is, let it be 10 volt. What is the total resistance? Total resistance R is equal to R1 plus R2. So R is equal to what? 5 plus 5, 10 ohm. Any doubt? Now what is the current? Current I is equal to V by R. What is the supply voltage? 10 volt divided by what is the total resistance? 10 ohm. So 10 volt divided by 10 ohm. So what is the current? 1 ampere. What is the current in the circuit? 1 ampere. So it's very easy to understand that in series resistors or combination of resistors in series, we can say that total resistance increases and current will be same and potential will be different across each resistor. It's a very important point. Now let me explain one more point with the same figure. So we got current as 1 ampere. So 1 ampere current starts flowing from the positive terminal. When it reaches 5 ohm resistor, what is the voltage consumed here? V is equal to, what is the formula? V equal to IR. So here V equal to what? What is current? 1 into resistance is what? 5. What is voltage? 5 volt. What is the voltage here? Current is again what? 1 and 1 only. What is the resistance? 5. Again 5 volt. So across 5 ohm resistor, voltage is 5 volt. Across the second 5 ohm resistor, voltage is also 5 volt. 5 plus 5 is equal to 10. So always remember, in resistor network, the total potential across each resistor should be matching to the supply potential. Then only your problem is correct. So it's better to check that. Now, for example, you can see another question. Let this be 10 ohm. Let this be 15 ohm. And let this be 100 volt. What is the total resistance? Equivalent resistance. Equivalent resistance stands for total resistance. What is that? 10 plus 15, that is equal to 25 ohm. Now, what is the current in this circuit? I equal to V by R. V is what? 100. By resistance is what? 25. So, what is the current? 4 ampere. I hope it is clear. 4 ampere is the current. Now, remember, what is the voltage across 10 ohm? Current into resistance. What is the current? 4 ampere into resistance is what? 10 ohm. So what is answer? 40 volt. Now somebody is asking, what is the voltage across 15 ohm? Now I can find out voltage across 15 ohm as what? Current is same, 4 into resistance is what? 15, 4 into 15, that is 60 volt. There is another way to find out the voltage. I know that voltage consumed across 10 ohm plus voltage consumed across 15 ohm should be equal to what? Supply voltage. So voltage consumed across 10 ohm is what? 40 volt. What is the total supply voltage? 100 volt. So what should be the voltage across 15 ohm? 100 minus 40 is equal to what? 60 volt. I hope it is clear. So again I am reminding you, the voltage across each, sum of the voltage across each resistor should be equal to supply potential in series combination. In series combination of resistors. I hope it is clear. Next we are going for parallel combination. Now what is the specialty of parallel combination? Let's see. Parallel combination of resistors. Let's see. In parallel combination, this is for one resistor, this is another resistor, this is another resistor, plus minus, current is coming, current is reaching this junction. See, when current is reaching this junction, current is seeing more than one path. That is a very important point. In series combination, current was seeing only one path. But so potential was different, current was same in series combination. Exact opposite happens in parallel combination. So what happens when the current sees this junction? One current flows through the upper path and one current flows through the lower path. So let this be R1, let this be R2. So what is the one end of resistor R1 is connected to supply potential, supply voltage. Other end of R1 is connected to negative potential. So remember, in series, in parallel combination, potential same. Potential same. What is different? Current is different. In parallel combination, potential is same, but who is different? Current is different. It's a very important point. I am repeating that. In parallel combination, potential same, current different. Potential same, current different. So, the incoming current, we know that V directly proportional to I, V is equal to IR, I equal to V by R. Now, this is Ohm's law, right? We have discussed in the last class. So, I is equal to the total incoming current I splits into two, I1 and I2. So, instead of I should write V by R. Instead of I1, I should write V by R1 plus instead of I2, I should write V by R2. So, V by R is equal to V into 1 by R1 plus 1 by R2. So, V gone. So, 1 by R is equal to 1 by R1 plus 1 by R2. This is the formula for 1 by R. Now, I don't like this formula because it gives me the answer 1 by R. So, in order to get the total resistance, I should take reciprocal of this R. So, what I am doing is that I am using this formula, equivalent resistance formula, R1 R2 divided by R1 plus R2. It's a shortcut formula. If for two resistors, for three resistors, there is another formula, equivalent resistance. Suppose there are three resistors, the formula is easy shortcut formula, R1 into R2 into R3 divided by R1 R2 plus R2 R3 plus R3 R1. The shortcut formula for three resistors. Now, again I am reminding you what is the specialty of this parallel combination. Current will be different. Current will be different. And what will be saying? Current will be different. Then potential will be same. Parallel combination potential will be same. Now, what is the specialty here? In parallel combination, total resistance decreases. Total resistance decreases. In parallel combination, total resistance decreases. Please remember that in parallel combination, total resistance decreases. Series combination, it was increasing. Now, let's do one problem. This is one resistor, maybe 10 ohm. This is another resistor, 15 ohm. And the supply potential is 100 volt. What is the total resistance here? Equivalent resistance is equal to what? What is the formula? Only two resistors. So you can use the tricky formula R1 R2 divided by R1 plus R2. What is the formula? 10 into 15 divided by 10 plus 15. 10 into 15 is what? 150. 10 plus 15 is what? 25. 150 by 25 is equal to what? 6 ohm is the total resistance. I hope it is clear. Now, what is the current? Current I is equal to what is the formula? V by R. What is V? V is what? 100. By resistance is what? 6. So, 100 by 6 will be the 100 by 6 ampere will be the answer. I think it will be 16.66. 16.66 ampere. 16.66 ampere. Always remember to write units. So, current I equal to V by R. Now, any doubt? Okay, so continuing. So continuing with the parallel combination, we are taking another example. 3 10 ohm resistors connected in 10 ohm, 10 ohm, 10 ohm. 3 10 ohm resistors connected in parallel. Plus or minus, this is 100 volt. So what is the current and total resistance? Total resistance. What is the formula? 10 into 10. So let me write the formula first. R1, R2, R3 divided by R1, R2 plus R2, R3 plus R3, R1. This is the formula for equivalent resistance. So R equivalent is equal to, what is the formula? What we have? All are 10. So 10 into 10 into 10 divided by 10 into 10 plus 10 into 10 plus 10 into 10. So 10 into 10 is what? 1000 divided by 100 plus 100 plus 100. So 1000 by 300, which is what? 10 by 3, which is what? 3.33 ohm. So when 10 ohms are 3 10 ohm resistors are connected in parallel, what we are getting? Total resistance is 3.33. That is the reason why I told you in parallel combination resistance decreases. Please don't forget that. Now I can teach you a shortcut. If there are n resistors, each with the resistance R, connected in series ആണെങ്കിൽ we have a shortcut formula in series. Take one resistor R series, R equivalent is equal to take one resistor into number of resistors. Shortcut formula. So R equivalent is equal to what? R into N. In parallel combination, R equivalent is equal to take one resistor divided by number of resistors. It's a shortcut formula for resistors connected in parallel. So R equivalent is equal to what? R by N. So what is this concept? If there are n resistors are there, each resistor value same. Each resistor is having resistance R. When they are connected in series, what you have to do? There is a simple formula. Take one resistor into number of resistors. In parallel combination, what you have to do? Take one resistor divided by number of resistors. Okay, I will give an example when to understand when to use this formula. If 100 ohm resistors connected in series. 100 ohm resistors connected in series. So I am thinking, what is the resistance value of one resistor? 100 ohm. How many resistors are there? 100. So resistor values are same. And when they are connected in which way? Series. So what is the formula? Shortcut formula, R series formula is what? Take one resistor into number of resistors. So 100 into 100. So what is answer? 10,000 ohm. What is 10,000? It is 10 kilo ohm. It is 10 kilo ohm. Now same question. Connected in parallel. What should be the answer? R parallel is equal to, what is the answer? Take one resistor divided by number of resistors. It's a shortcut formula. Remember students, you should use this formula only when the resistor values are same. If one resistor is 1 ohm and the other one resistor is 10 ohm, you cannot use this formula. If one resistor is 5 ohm, other one is 20 ohm, you cannot use this formula. If all resistors are having same value, then only you should use this formula. So R parallel equal to R by N. So what? 100 ohm by 100. What is answer? 1 ohm. That is a shortcut formula when resistor values are same when they are connected in parallel. Any doubt? I hope it is clear. So let's continue. If there are, not that, what is the ratio of n resistors connected in, first one, series to parallel, connected in series to parallel. What is the ratio of n resistors connected in series to parallel? N resistors, I forgot to write one line. N resistors, each with resistance R. Each with resistance R. So there are n resistors, but every resistor is having same value. We have to find out the ratio of n resistors connected in series to parallel. So what is our formula? R series to R parallel. Resistors in series to resistors in parallel ratio we have to find out. Now what is the formula for R series? Take one resistor into number of resistors. What is the formula for R parallel? Take one resistor divided by number of resistors. So Rn, this denominator n moves to the numerator by R. So what happens? N square by 1 or n square is to 1. Now what is the ratio? R parallel to R series. Resistors in parallel to resistors in series. Take one resistor divided by number of resistors. Take one that is in parallel. Series, take one resistor into number of resistors. So R by N R N. So R gone. So 1 by N square or 1 is to N square. I hope it is clear. I hope it is clear. Next, you should understand that kilo is 10 raised to 3. Mega 10 raised to 6. Giga, some say pronounce it as giga, 10 raised to 9. Tera, 10 raised to 12. Peta, 10 raised to 15. Then milli, 10 raised to minus 3. Micro, 10 raised to minus 6. Nano, 10 raised to minus 9. Pico or pico, 10 raised to minus 12. Femto or Fermi, 10 raised to minus 15. You should know these values. Kilo, mega, giga, tera, peta, milli, micro, nano, 10 raised to minus 9, pico, 10 raised to minus 12, femto or Fermi. Why I am saying that? For one question, you got an answer 10,000 ohm, which you can written as 10 kilo ohm. Okay. One question, it is given resistance value is 1 mega ohm. You should understand what is 1 mega, 10 raised to 6 ohm. I hope it is clear. Okay, continuing. Resistors in parallel combination. Resistor connected across common points. Potential difference across each resistor is same. That is the speciality of parallel combination. Total current is the sum of current through individual resistors. Why? Suppose total current is coming to this junction. This current be I1, this current be I2, this current be I3. Then all these current combines at this point. Again the return current is what? I. So from positive terminal I current comes, it reaches the junction X, it gets split. So how many paths are there? 3 paths. Some students might be saying, sir, there are 4 paths. Why are you saying 3 paths? The fourth path is voltage and not voltage, voltmeter. We know that resistance of voltmeter is what? Very high. So no current. We can imagine, not imagine, we can assume that no current flows through the voltmeter. Why? Because voltmeter is having very high resistor. So no current resistance. So no current flows through the voltmeter. So when at X the current gets split and at Y all these currents combine to get the original current I, and it goes back. Resistors in parallel. So what happens in the parallel combination? Total resistance decreases. We have seen in series combination what we were seeing. Three different resistors are there. Again voltmeter is connected, but no current flows through the voltmeter because voltmeter resistance, it is not shown. It is very high. So current through voltmeter will be almost zero. Not perfectly zero, almost zero. So there is only one path for the current to flow. Current does not pass through voltmeter because its resistance is very high. Here total resistance increases. What is it? Total resistance R1 plus R2 plus R3. Now what is the other point? Potential difference across the combination is the sum of potential difference across the individual resistors that we have seen. In series combination, if you add the potential across R1, let it be V1, let it be V2, let it be V3. What is the supply potential V? Voltage across resistor R1 plus voltage across resistor R2 plus voltage across resistor R3. Very important point. Now, what is the other point? Same current flows through each resistor that we have seen. Resistors are connected end to end, back to back. We have seen all these things. Okay. Ammeter is connected in what? Series. What will be the resistance of ammeter? Very small. So that is the reason why I am giving very small figure. Here what? Very large figure. Why? Because voltmeter is having high resistance. Voltmeter does not allow the current to pass through it. We explained that. So continuing. An electrical lamp whose resistance is 20 ohm and a conductor of 4 ohm resistors are connected to 6 volt battery. Calculate total resistance. So how many resistors are there? Circuit actual resistor is 4 ohm. The lamp is having resistance is what? 20 ohm. So what is the total resistance? R equivalent. Total resistance is what? 4 plus 20 is equal to 24 ohm is the total resistance. I hope it is clear. Connected to a 6 volt battery. So voltage is what? 6 volt. Calculate total resistance. The current through the circuit. I equal to what? V by R. V is what? 6 by resistance is what? 24. What is 6 by 24? 1 by 4 ampere. That is 0.25 ampere. Current through circuit, potential difference across electric lamp and conductor. So, electric lamp and conductor, I think it should be resistor across the electric lamp. What will be the potential difference across the resistor? Let this potential be V1. V1 equal to what? IR1. What is current here? 0.25 into R1 is what? 4. 0.25 is what? 1 by 4 into 4. So, what is the voltage here? 1 ohm, 1 volt. What is the voltage here? V2 is equal to what? I into R2. Why I am not writing I2? Because it is series combination, current is same. So current V2 is equal to I into R2. Current is what? 0.25 into R2 is what? 20. What is 0.25? 1 by 4 into 20. So V2 is equal to what? 5 volt. Now, how to check if your answer is correct or not? 1 volt plus 5 volt is equal to supply voltage 6 volt. So, potential difference across each resistor, sum of potential difference across each resistor should be equal to applied voltage. So, 1 plus 5, 6. So, our answer is correct. I hope it is clear. Any doubt? Now, students, it's better to by heart some fractions. You should remember 1 by 2, 0.5 ohm, 1 by 3, 0.333, 1 by 4, 0.25, 1 by 5, 0.2 ohm, 1 by 8, 0.125, 1 by 16. Oh, sorry. There is no need of writing this ohm. I don't know, for some reason I wrote ohm. 1 by 16 is what? 0.0625. Students, my request is that you should by heart these fractions, because these fractions you can expect anytime. And always remember, 1 by 1.6 is what? 0.625. That makes your calculation easier, because charge of electron there is 1.6. So please do remember these fractions also. So I hope it is clear. This problem is done. Let's continue. Yeah, its solution is also given, but we have already found out. Parallel combination we have already seen. An electrical circuit showing the combination of resistors. Yeah, these two are what? Parallel. These three are also parallel, and the combination is connected in series. These two parallel. These two not two. These are, there are three resistors. These are in parallel, and the combination is connected in series. This is the supply voltage. Next is heating effect of current. When current flows through a resistor, heat is produced. This is known as Joule's heating effect. See, my wife is telling me to change the bulb, but when I touched the bulb, I was feeling heat. Why? Because of Joule's law. Joule's law tells you that whenever there is a current flow, there will be heat produced. So H equal to I squared RT. H equal to what? I squared RT. What is I? Current. What is R? Resistance. What is T? Time. So H equal I squared RT. So heat produced in a current carrying conductor is equal to what? Square of current and resistance and time during which current flow. So what is the heat? What is Joule's law? Joule's law tells you that the heat, okay, let me write the statement. Heat produced in a current carrying conductor is equal to product of square of current and resistance and time during which current flow So H equal to I squared RT. So remember, from this equation we can understand that heat more depends on current, because there is a square. So heat has more dependence on current because there is square, I squared RT. Now the same I squared RT can be written as I into R into T. Now what is I into R? V. So H equal to what? VIT. That is another equation for heat. Remember, unit of heat is joule. Unit of heat is joule. Okay. So what are the equations for heat? I squared RT one equation, VIT is one equation. Now instead of VIT we can have one more equation. V into, instead of I am writing V by R into T. So what is another equation? V squared I equal to V by R. So V square T by R. So we got one more equation for heat, V square T by R. Any doubt? These are the different equations of heat generated in a conductor. Now applications, electric iron which uses heating effect, heater, geyser, toaster, electric bulb, fuse. All these devices use the heating effect of current. Okay. Next, power. What is power? Listen. Power is the rate of work done. Power is the rate of work done. So, power is equal to work done by time. Power is equal to work done by time. In electrical circuit, work done is equal to heat. Work done is equal to heat. So, power is equal to heat by time. So, I squared RT by T. So, T gone. So, power is equal to what? I squared R. Power equal to what? I squared R. This is the equation for power. So, the same equation can be written as I into R instead of I square. What is I into R? V. So, we got one more equation for power, that is VI. So, the same equation can be written as power equal to V into, instead of I, we can write V by R. So, power equal to what? V square by R. So, we got three equations for power. What are they? Power equation I squared R. Power is equal to V square by R. Power equal to VI. These are the different equations for power. These are the different equations for power. Now, SI unit of power is watt. SI unit of power is watt. Commercial unit of power is kilowatt. Commercial unit of power is kilowatt. Remember, 1 kilowatt is equal to 1000 watt. 1 kilowatt equal to 1000 watt. Now, there is one more point. Unit of heat is heat and also energy. Heat and energy have unit joule. Here, you should also study one more unit, kilowatt hour. Kilowatt hour. It is the energy consumed by an appliance. Appliance mean home appliance, we know mixie, TV, fridge, everything. It is energy consumed by an appliance of 1000 watt when it is used for 1 hour. When it is used for 1 hour. For 1 hour. So, 1 kilowatt hour kWh is equal to 1000 watt into 1 hour. 1000 watt into 1 hour is what? 3600 seconds. So, 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. What is 1 kilowatt hour? 3.6 into 10 raised to 6 joule is 1 kilowatt hour. Now, what is 1 kilowatt hour? It is the commercial unit of electrical energy. It is the commercial unit of electrical energy. What is that? Kilowatt hour. 1 kilowatt hour is the commercial unit of electrical energy. So remember, now I am asking you one question. Suppose I am calling two students, Raju and Radha. I am telling Raju to move 10 desks from the classroom to out to the ground. Raju is doing this task in 1 hour. Same task I am telling to Radha also, to move 10 desks from the classroom to the ground. Radha is doing the same task in half an hour. Who is doing more work? So I am repeating the question. I am telling Raju to move 10 desks from classroom to the ground, and Raju is doing in 1 hour, and Radha is doing the same task in half an hour. Who is doing more work, Raju or Radha? Please think. Okay, I am giving you the answer. The more work is done by whom? The question itself is wrong. Because what is the work assigned to Raju to move the 10 desks from classroom to the ground? He is doing that work. What is the work assigned to Radha? The same work. Radha is also doing the same work. Radha is also done the same work. So work done is same. But now you will be thinking, sir, there is some difference, no sir, between Raju and Radha. Yes, what is that difference? Power. Here, Radha does the same work with lesser time. So Radha is having what? More power. Power equal to what? Work done by time. Power is the rate of work done. It is not written that? Yeah, I think it's in the previous page. What is power? Rate of work done. Here it is, the definition is what? Rate at which electrical energy is consumed or dissipated. Dissipated means use. The rate means what? Denominator has to be time. Rate at which electrical energy is consumed or dissipated is called power. What is power? Work done by time. In electrical circuit, work done equal to heat. So what is heat? I squared RT by T. I hope it is clear. Commercial kilowatt hour, I also explained 3.6 into 10 joule. That is also done. Energy consumed in electrical appliance, commercial into kilowatt hour or unit. See, commercial unit of electrical energy is kilowatt hour. Commercial unit of electrical energy is kilowatt hour. Commercial unit of power is kilowatt. I hope you do remember that. Commercial unit of what? Electric power is kilowatt. Commercial unit of electrical energy is kilowatt hour. So there is a difference. What is the commercial unit of power? Kilowatt. That is 1000 watt. What is the commercial unit of electrical energy? It is kilowatt hour. I hope it is clear. Domestic electrical circuits. What we have? A main supply, live wire and neutral wire. I told you live wire, or it is also called phase wire. And the other one is what? Neutral. Why? What is the role of neutral? We discussed it in the previous class. Because it is the neutral which provides potential difference. According to Ohm's law, there will be current flow only if there is potential difference. Now, how I should connect an appliance? I should connect an appliance in this way. Because at one end we have 230 volt. At other end of the appliance, what we have? 0 volt. So there is difference in potential. So current will flow. Electric meter, main fuse. Fuse is very important because I will explain. Suppose there is a electric pole and lines will be coming from the pole to our home. Okay, suppose this is our house. These lines will be coming here. Here there will be an electrical circuit, electric meter. In meter, when you zoom it, you can see fuse wire. This is the supply line and there should be a fuse wire. What is the role of this fuse wire? Fuse wire is a combination of tin and lead. It is having very low melting point. Low melting point means what? When large heat is there, not large heat, when this wire is heated, it will melt. So suppose, unfortunately, I will explain a situation. This is phase and this is neutral. So this is connected to this our fuse wire. Fuse is connected in the phase wire, not on the neutral wire, because neutral wire does not have potential, zero potential. Always remember, fuse wire is connected to the phase wire. So when large current flows, what happens? Fuse wire melt because of Joule's law. Because H equal to what? I squared RT. When large current flows, fuse wire melt. So what? There is no. This is our, suppose this is our house or any electrical component. If large current flows, what happens? Suppose I am having an Apple laptop, which is very costly one. If our house is not completely properly wired, if you are not using proper fuse wire, what happens? There is a chance that high current may flow through the wire. But what is the advantage of having fuse? What is the advantage of having fuse? When the fuse wire melt, what happens? Large current is getting prevented to flow to the laptop. So our laptop, Apple laptop, costly laptop is saved because of fuse wire. So my question, should you use copper wire as fuse wire? No, copper is having high melting point. What is the problem? Copper does not melt easily. Copper will send large wire to the laptop. It may get damaged. So what combination you should be using? You should be using tin and lead combination. What is the advantage? Low melting point. So it melts easily. So what circuit is broken and no current flows through the laptop, Apple laptop. So fuse wire is very important. And then there is phase and neutral. Fuse wire is always connected in the phase wire because it carries the current. Then MCB, miniature circuit breaker. Yeah, then separate circuit for appliances with different power rating. For example, generally we have a 10 ampere, up to 10 ampere switch and a high power switch you can see with a 3 pin. It is required, one pin will be very big pin and 2 smaller pins. That you have seen, right? 3 pin connection. One pin will be bigger. Why there is different power rating? Because mixie, fridge, washing machine, AC, it consumes large power. So these devices will be costly also. So you have to apply given separate fuse wire for them. Otherwise, because of high current, it may get damaged. So if there is different power rating, you should have separate power connection. Because generally all the mobile chargers work on very low power. But these devices like fridge, washing machine, mixie, juicer, then oven, they require large amount of power. So separate connection should be given. Otherwise, what happens when you switch on the mixie, TV will have some issue because it requires large power. So if a device is requiring large power, there should be separate connection for the large power required devices. Safety devices, electric fuse we explained. Earthing. Earthing is important. In earthing, what happens? We are providing a connection directly to the earth. Earth is like a sink. Earth absorbs what? High current. If proper earthing is not there in your house, there is a chance of getting shock. So if earthing is there, earthing means nothing, we will be sending a wire, earth wire to the ground. So what happens? Excess current flows to the ground. That is the advantage of having earthing. Earthing provides a low resistance path. Suppose I am getting touched to a phase wire. If proper earthing is done, the current will go to the earth, not through my body. So I won't get shock. you don't need to study in detail. Just remember that earthing is very important for leakage current. So excess current is there, that current should go to earth, not to your body. That is the point about earthing. Domestic electrical circuit: cell, battery, plug key, closed, open, wire join, wires crossing without joining, electric bulb, resistor. Variable resistor is also called rheostat. Ammeter represented by A, voltmeter by B. We have seen that. Application: electrical heating device based on Joule's law of heating, electric iron, toaster, water heater, oven, kettle. Usually made of alloys which have high resistivity. So heating device should have high resistivity. Do not oxidize, burn easily at high temperature. Heating device is using the heating effect. It should not be burning. It should get heated, but it should not be burning. So it do not oxidize. Oxidize means what? React with oxygen. Should not be burning easily at high temperature. High temperature should be there, but it should not be burning. Have high melting point. So remember, heating device should have high melting point, but fuse wire should have low melting point. In bulb, we use tungsten. Tungsten is having high melting point. Should I use tungsten for fuse wire? No. What is the problem of using tungsten for fuse wire? Tungsten will allow the large current to your home, to your laptop. It may get damaged. Should I use tin lead combination as heating element in a bulb? No. What happens? When large current flows, tin lead easily melt. So you won't be able to get the light from the bulb. So remember, tungsten is used as heating element. Tin lead combination is used as fuse wire. Fuse wire, low melting point, and heating effective device should have high melting point elements. Electric bulb. Tungsten filament gets heated to high temperature and emits light. Tungsten has high melting point. How much? 3380 degrees Celsius. That is a huge melting point. Bulb filled with nitrogen and argon gas to prolong filament life. To extend the life, we use what? Nitrogen and argon inside the bulb. You have seen the figure, right? Of bulb, and there will be filament. Tungsten filament. This tungsten is having what is the specialty? High melting point. Fuse wire, low melting point. Tungsten, high melting point. I hope it is clear. Fuse, safety device to protect electrical circuits and appliances. Made of a wire with a low melting point, usually an alloy of tin and lead. Alloy means combination. When excessive current flows, the fuse wire melt and breaks the circuit. Rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere. So what is rated as 1 ampere? If a fuse wire is rated as 1 ampere, maximum current it can permit is 1 ampere. If it is more than that, it will melt. Similarly, 2 ampere is the limit. For AC, we should have high power rating fuse wire, because AC requires large current. So students, we can see the problems in current electricity. Let's start. A resistance wire of 10 ohm is stretched 10 times its original length. 10 times its original length. What will be the new resistance and new resistivity? What will be the new resistance and new resistivity? See, resistance wire of 10 ohm. So what is the equation for resistance? R equal to rho L by A. That resistance is given as 10 ohm. It is stretched to 10 times. So what will be the new length? 10 times original length. Now students, it is very important to understand that when a wire is stretched 10 times, it is understood that its area decreases by 10 times. The person who have put this question won't say or will not comment about the area, cross-sectional area. You should understand that when the length increases 10 times, then the cross-sectional area decreases by 10 times. When length increases 5 times by stretching, cross-sectional area decreases by 5 times. That is a very important point. Suppose this is the original wire. If it is increased, say 2 times, what happens? The cross-sectional area decreases by half. That is the common logic. So what will be the new resistance? R dash. Rho remains the same. What is this? Rho. What is rho? Resistivity. Resistivity. What is the other name for this? Or specific resistance. So R dash is equal to rho into L dash by A dash. R dash is equal to rho into L dash by A dash. See, I am not writing rho dash. Why? Resistivity remains constant even if you change length or cross-sectional area. If you change length or cross-sectional area, resistivity will not change. But still, the person who have put this question is asking what is the new resistivity. It's a trap. Don't fall into that trap. Question is asking you what is the new resistivity. What should be your answer? Resistivity does not change. So R dash equal to rho L dash by A dash. So that is equal to rho into L dash is what? 10L divided by A dash is what? A by 10. So this denominator 10 goes to the numerator. So rho L by A into 10 into 10. So rho L by A into 100. Rho L by A into 100. So what is rho L by A? It was given that rho L by A is what? 10 ohm. So what is the answer? 10 into 100. So what is the answer? 1000. 10 into 100. What is the answer? 1000 ohm. What is the answer? 1000 ohm or 1 kilo ohm is the answer. Or 1 kilo ohm is the answer. I hope it is clear. I hope it is clear. Now what about the resistivity? Resistivity does not change. Resistivity does not change. Resistivity does not change. Please do remember, resistivity does not change. I hope it is clear. I hope it is clear. So next question. A resistance wire of 16 ohm is cut into 4 equal parts. Each parts are connected in parallel. Each parts are connected in parallel. What will be the equivalent resistance of the combination? Equivalent resistance of the combination. Resistance of the combination. See, what is the original resistance? 16 ohm. 16 ohm. It is cut into 4 equal parts. So, these are the 4 equal parts. Now, these 4 equal parts are connected in parallel. Now, remember, R equal to rho L by A. That is equal to 16 ohm. When we cut this resistor into 4 equal parts, what will be the new resistance? Rho does not change. Always remember rho, that is resistivity or specific resistance, do not change. When you cut the wire into 4 equal parts, what is the new length? New length will be 1 by 4 times original length. Now remember, when you cut a resistance wire, cross-sectional area does not change. When you stretch a wire, length increases, by same amount, cross-sectional area decreases. I think I should write it here. When you cut a wire, length decreases, but cross-sectional area does not change. But cross-sectional area does not change. When you stretch a wire, length increases, cross-sectional area decreases by same amount. Cross-sectional area decreases by same amount. Decreases by same amount. Now, one more time. When you compress a wire, when you compress a wire, length decreases, but cross-sectional area increases. Okay. Cross-sectional area increases. So do remember this. Now R dash equal to what? Rho L by 4. Now, is there any change in cross-sectional area? No. So cross-sectional area remains the same. So R dash is equal to what? Rho L by 4A. Rho L by 4A. Now, what is rho L by A? Rho L by A is the original resistance 16 ohm. So R dash is equal to 16 by 4. So R dash is equal to 4 ohm. Any doubt? R dash is equal to what? 4 ohm. Any doubt? I hope it is clear. So this is the one branch resistance. How many branches are there? 4 branches. So 4 ohm, 4 ohm, 4 ohm. Now these 4 ohms are connected in what way? Connected in parallel. So I told you the shortcut formula for parallel combination. Take one resistor divided by number of resistors. One resistor is what? 16 ohm. Divided by number of resistors is what? 4. 16 by 4 is equal to what? 4 ohm is the answer. Any doubt? Sorry. That's a mistake. 16. One resistor is what? 4 ohm. Divided by number of resistors is what? 4. 4 by 4. 1 ohm is the answer. I hope it is clear. Any doubt? So please remember this point. When you stretch a wire, length increases, by same amount, cross-sectional area decreases. When you cut a wire, length decreases, no change in cross-sectional area. When you compress a wire, length decreases, cross-sectional area increases. In all these cases, resistivity remains constant. Resistivity remains constant. Resistivity remains constant. In all these cases, resistivity remains what? Constant. Now, next question. This is 3 ohm. This is 7 ohm. Then we have a 10 ohm resistor. Then we have a 5 ohm. Then we have a 10 ohm here. What is the resistance between A and B? That is the question. A, B, C, D. What is the resistance between A and B? When the question asks what is the resistance between A and B, you should give an extension at that point. That means current is entering the circuit through this A and B. Now how to solve this? You should understand that these 3 ohm and 7 ohm are in series. Why? Because there is only one path between 3 ohm and 7 ohm. Because I told you many times, in series combination, there will be only one path between resistors. So 3 ohm, 7 ohm are in series means what? You can replace it with 10 ohm, 3 ohm plus 7 ohm, 10 ohm. And there is another 10 ohm. This 10 ohm. Then we have a 5 ohm. Now remember, and here we have a 10 ohm. Now you can solve these two 10 ohms. They are in parallel. Why they are in parallel? Because when you start from this position, there is more than one path. Whenever you see more than one path, it's a parallel combination. So these two 10 ohms are parallel. So what is the answer? 5 ohm. This 5 ohm is in series with this 5 ohm. And here we have a 10 ohm extension. So 5 plus 5 is what? 10 ohm. Because these two are in series, only one path. So 1 10 ohm and we have another 10 ohm. Another 10 ohm. So what is the equivalent resistance? These two are in parallel. These two are in parallel. So what is the answer? Take one resistor divided by number of resistors, 5 ohm. Now when some students see this, they will think, sir, why can't we take this 5 ohm and this 10 ohm as parallel? See, when you solve a circuit, its ends should be common. See, here you can take these two 10 as parallel because both have common. But you can't solve this 10 ohm and this 10 ohm as parallel. Why? Here it have a component, but the other side it is not having a component. So you can solve two resistors as parallel only when they have common ends. Here you can solve they are in parallel because they have component. This 10 and this 10 are in parallel, but we cannot solve that. You will be able to solve resistance circuit only when they have components if they are connected in parallel. Please do remember that. So now can we take this 10 ohm and 7 ohm as parallel? No, it is having component at only one side, other side it is having another resistor. So you can't solve it directly. So what we are doing? First of all, you are solving 7 ohm, 3 ohm as series. Then the total is 10 ohm is parallel to this 10 ohm. Here you can solve because it has components. It's a very important point. Next question. 10 ohm. 10 ohm. Then 15 ohm is connected to 10 volt. So you have to find out R equivalent resistance, current, then voltage across 10 ohm, voltage across 15 ohm, means both 10 ohm and 15 ohm. Now first of all we should find out the equivalent resistance. What is the equivalent resistance? These two 10 and 15 ohm are in parallel. So 10 ohm, first one is 10 ohm. Here what should be the formula? R1 R2 divided by R1 plus R2 is the formula for equivalent resistance. So 10 into 15 divided by 10 plus 15. plus minus 10 volt. So current is flowing. So what is the equation here? 10 into 15 is what? 150. 10 plus 15 is what? 25. What is the answer? 6 ohm. That 6 ohm in the next figure, that 10 ohm is in series with 6 ohm. Here we have a 10 volt. So what is the total resistance? 10 plus 6 is equal to 16 ohm. What is the current? Current I equal to V by R. So V is what? 10 by 16. 10 by 16 is what? 5 by 8. So this is the total current, 5 by 8, which is 0.625 ampere. So what is the total current? 0.625 ampere. I hope it is clear. Now we have done equivalent resistance current in the circuit. Now voltage across first 10 ohm. Remember, let the current 0.625 ampere start from the positive terminal. What is the voltage across this 10 ohm? Voltage is equal to current into resistance. So what is the current? 0.625 into resistance is what? 10. So what is the answer? 6.25 volt. Any doubt? 6.25 volt is the voltage here. Now what will be the voltage across these two combinations? It's very simple. Suppose you have 10 mangoes and here we are consuming 6.25 mangoes. So how much mangoes are left here? 3.75. So it's very easy. Voltage across upper 10 ohm is also 3.75 volt. Voltage across lower 10 ohm, 15 ohm is also 3.75. Why we got same value? Because we know that these two are in parallel. In parallel combination, voltage is same. I hope it is clear. So you can check your answer because the voltage drop across 10 ohm 6.25 plus the voltage drop here is what? 6.25 plus 3.75. What is the answer? 10 volt. That means your answer is done. It is correct. I hope it is clear. I hope it is clear. Next question. Calculate number of electrons constituting 1 coulomb of charge. So the question tells you how much electrons are required to get 1 coulomb of charge. So remember Q equal to what? Ne. What is Q? Charge. Charge is given as 1 coulomb. N I don't know. I am putting a question mark. E is what? Electron, which is 1.6 into 10 raised to minus 90. So how much electrons are required? N equal to Q by E. So 1 by 1.6 into 10 raised to minus 19, which is 1 by 1.6 is what? 1 by 1.6 into 10 raised to plus 19, which is what? 0.625 into 10 raised to 19, which is what? 6.25 into 10 raised to 18. So we are understanding that much amount of electrons are required to give 1 coulomb charge. So 1 coulomb charge contains this much electron. So 1 coulomb contains what? This much electron. Okay. So next. Next question. How much energy? We are doing textbook problems. Is given to each coulomb of charge passing through 6 volt battery. See, energy given by battery is equal to, remember, energy given by battery. That is also called what? Work done. Work done is equal to, what is the formula? Charge into potential difference. Please remember this formula. Work done is equal to charge into potential difference. Or you should remember, potential difference is equal to work done by charge. Potential difference is equal to work done by charge. So work done is equal to, potential difference is a single term. Potential difference is a single term, is equal to work done by charge. So what is work done? Charge into potential difference. That is the point. So how much energy is given means what? Charge. What is the charge here? Here charge is 1 coulomb. Here what is the charge? Through given to each coulomb. Each coulomb means what? Charge is 1. Into potential difference is what? 6 volt. So what is the energy? 1 into 6. 1 coulomb is 6 joule. What is the unit of energy? Joule. So please note that. I hope it is clear. Now, on what factors resistance of a conductor depends? Resistance of a conductor depends on, first one, length, then cross-sectional area, then nature, and the last one, temperature. So resistance of a conductor depends on length, cross-sectional area, nature and temperature. Please do remember that. Okay, please do remember that. These are the factors on which resistance of a conductor depends. Now, 3 resistors, 5 ohm, 8 ohm, then 12 ohm are connected in series. So you have to draw a diagram. So I am directly drawing the diagram. 5 ohm and 8 ohm and 12 ohm are connected in series across a battery of 3 cells, 2 volt each. See, we are using 3 cells, 2 volt each. 2 volt, 2 volt, 2 volt. And we have a plug key. The mid dot indicates it is closed one. So what we have to do? What is the total resistance? Total resistance is what? 5 plus 8 plus 12. So 13 plus 12, that is 25 ohm. Now what is the current? Current I equal to what? V by R. So total voltage is what? 6 volt divided by resistance is what? 25. So what is answer? 6 by 25 ampere is the answer. See, when cells are shown here, you have to take the total of the potential. 2 volt plus 2 volt plus 2 volt, 6 volt. Total resistance is already taken. Okay. I hope it is clear. This 6 by 25 is 0.24 ampere. 6 by 25 is 0.24 ampere. Now, the question tells you to find out the add ammeter and voltmeter to the circuit. The question has a B part also. You have to draw, add an ammeter and voltmeter. So 5 ohm, 8 ohm, then what? 12 ohm, This is the original circuit. I have to add ammeter and voltmeter. Ammeter in the circuit, voltmeter across 12 ohm. The question tells you to add ammeter to the circuit. It is not specified to a resistor. Ammeter always connected in what? Series. And voltmeter to the 12 ohm. I forgot to put switch plug key. Voltmeter across 12 ohm. Okay. So current again 2 volt, 2 volt, 2 volt. Plus minus. Current is flowing. What is the current flowing? 0.24 ampere. So what is the reading of the meter? 0.24 ampere. Now there is a problem. We have to find out the voltmeter reading. Now what is voltmeter? Voltage is equal to current into resistance. So what is the current? 0.24 into resistance is what? 12. What is the resistance? 12. So what is the voltage across the 12? 2.88 volt. If you do the calculation, your answer will be 2.88 volt. The answer is very simple. Voltage is equal to current into resistance. Current in the circuit will be same. Why? Because it is a series combination. Now some students might be overthinking. Sir, there is an additional path. You told you whenever you see more than one path, it's a parallel combination. But actually, there will not be any current flow here. Why? Because I know the voltmeter resistance is very huge. So all the current flows through 12 ohm and the voltage across 12 ohm will be 2.88 volt current into resistance. I hope it is clear. Okay. Next question. Judge the equivalent resistance. Judge the equivalent resistance when following are connected in parallel. Following are connected in parallel. First one, 1 ohm and 6 ohm and 106 ohm. 1 ohm and 106 ohm. Second one, 1 ohm, 103 ohm and 106 ohm. When the point here is that when the resistors are connected in parallel, comma, the equivalent resistance is smaller than smallest individual resistance. That is a very important point. So in both case R equivalent will be less than 1 ohm, because when resistors are connected in parallel, the equivalent resistance will be lesser than the smallest resistance. What is the smallest resistance in both cases? 1 ohm. So if you find out the equivalent resistance, its value will be lesser than the smallest individual resistor. It's a very important point. I hope it is clear. Next, an electric lamp of 100 ohm, electric lamp of 100 ohm, a toaster, bread toaster, a toaster of 50 ohm, and a water filter of 500 ohm are connected parallel to a 220 volt source. 220 volt source. What is the resistance of an electric iron connected to the same source that take as much current as all three appliances. And what is the current through it? It's a lengthy question. You can expect it as a 5-mark question. Now, first, electric lamp, then what? A toaster, let this be a toaster, and a water filter, let this be the water filter, connected in parallel. So, electric lamp and a toaster and a water filter. I'm just giving different shapes to identify that. First one is what? 100 ohm. And the second one is what? 50 ohm. And the water filter is what? 500 ohm. They are connected in parallel. Okay. So, what is the resistance of an electric iron? See, what is the equivalent resistance formula? 1 by R1 plus 1 by R2 plus 1 by R3. Either you can use this formula or equivalent resistance. Other formula is what? R1, R2, R3 divided by R1, R2 plus R2, R3 plus R3, R1. So, equivalent resistance formula is what? So, I am doing the common method. Not here. Here, first case, it should be 1 by R equivalent. That is the problem with this formula. So, 1 by R equivalent is equal to 1 by 100 plus 1 by 50 plus 1 by 500. Isn't it? So, when you do this, when you solve this, you will get what? 16 by 500. 16 by 500. I hope it is clear. 500, 50, 100. You know how to take LCM, right? So, if you take 550, what we will be getting? 10, 1, then what? 2. If you by 5, what you will get? 5, 1. Okay. If you so 2, 1. Okay. Okay, so equivalent resistance is, what is equivalent resistance? We got R 1 by R equivalent equal to 16 by 500. So R equivalent is equal to 500 by 16. that is equal to 31.25 ohm. This is the equivalent resistance. Now it is given that what is the resistance of an electrical iron connected to the same source that take as much as current all three appliances. What is the current through it? So what is the equivalent resistance? 31.25. Now what will be the resistance of electrical iron? The same only, because it is connected to same source. It is given that it is connected to same source. It is connected to what is the source voltage? 220 volt. Here, what is the specialty? This combination total resistance and that total resistance is the same resistance that is having that is an electric iron is having. So what is the resistance of electrical iron? 31.25. Now we have to find out the current it is taking. Current I is equal to what is the formula? V by R. Current I is equal to what is the formula? V by R. What is the voltage? What is the voltage? 220 divided by resistance is what? 31.25 is the resistance we got. So if you solve that, you will get the answer. 220 divided by 31.25. So please do that calculation, then you will get the answer. 220 divided by 31.25, which is almost 7.01. 7.04 ampere. Almost 7. We know that 220 by 31 will be what? Almost 7. So what is the current? 7 ampere. That is the current taken through it. So first of all, what we are doing? Bulb, toaster and a water filter. Resistance values are given. We have found out the total resistance, and the total resistance is what? 31.25. So it is given that electric iron is having the same resistance. So what is the resistance of electric iron? That is also 31.25. What will be the current taken by the electrical iron? So what is the current? Suppose this is electrical iron, then what is its resistance? 31.25. What is the voltage here? What is the voltage here? 220. So what will be the current? 220 divided by 31.25, that is equal to 7.04 ampere. That is equal to what? 7.04 ampere. That 04 is not required. You can simply write 7 ampere. Next question. How can three resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm, first case, second case 1 ohm. So students, we are given 3 resistors. How will you connect it to get a total resistance of 4 ohm? How will you connect it to get a total resistance of 4 ohm? So let's see. First of all, we should connect 2 ohm resistance in series with 3 ohm and 6 ohm. Combination in parallel. So what is the total resistance here? Here we have 2 ohm and this 3 ohm and 6 ohm are parallel. So what is the formula? R1 R2 divided by R1 plus R2, that is 3 into 6 divided by 3 plus 6. So it becomes what? 3 into 6, 18 by 3 plus 6 is what? 9. So 18 by 9, 2. So this is also 2 ohm. So these 2 ohm are in what? Total resistance will be 4 ohm. So how to connect? Which is the correct connection? First resistor in series with a parallel combination of 3 ohm and 6 ohm. Then we will get the total resistance as what? 4 ohm. Next, what we have to do? We have to connect somehow by connecting we have to connect somehow so that the total resistance should be what? 1 ohm. Now, how to get 1 ohm resistor? So I am remembering one point. In parallel combination, the total resistance will be lesser than the smallest individual element. What is the smallest individual element? 2 ohm. So in order to get 1 ohm, what is the only option? All should be connected in parallel. So 1 ohm, 2 ohm, 1 ohm, 3 ohm, 2 ohm, 3 ohm, 6 ohm, all connected in parallel. That is the only option. So R equivalent is what? What is the formula? R1, R2, R3 divided by R1, R2 plus R2, R3 plus R3, R1. So R1, R2, R3 is what? 2 into 3 into 6 divided by 2 into 3 plus 3 into 6 plus 6 into 2. 2 into 3, 6, 6 into 6, 36 divided by 6 plus 18 plus 12. So 36 by 18 plus 12, 12 is what? 30 by 6 is what? 36. So what is 36 by 36? 1 ohm. Any doubt? So how to get 1 ohm from this combination? All should be connected in parallel. So how did I concluded that? Because I know that in parallel combinations, total resistance will be lesser than the smallest individual resistance. So in order to get a total resistance of 1 ohm, which is the smallest one, 2 ohm, it has to be lesser. 1 ohm is lesser than 2 ohm. So that means all should be connected in parallel. I hope it is clear. Next question. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. So what is the total charge? 96,000. Time is what? 1 hour, that is equal to 3,600 seconds. Potential difference of what? 50 volt. So what is the heat generated? They are asking for the heat generated. Now it's very important that work done is equal to what? Work done is heat. Work done is equal to heat. Work done is equal to what? Charge into potential difference. So what is the charge here? 96,000. What is the potential difference? 50. So 96,000 into 50 will be the answer, which will be 48 lakh. So as you can express it in kilojoule. So 4.8 into 10 raised to 6 joule. 4.8 into 10 raised to 6 joule. Now it became 48 lakh. I hope it is clear. 4.8 into 10 raised to 6 joule. Any doubt? What is heat? They are asking for heat. You should understand that heat is work done. What is the formula for work done? Work done is equal to charge into potential difference. Charge into potential difference. That work done is heat. So there is no need of time. Listen, there are students who think that all the variables, all the quantities or all the values given in a question have to be used. There is no such rule. Here time is given just to confuse you. They are asking only for heat. For finding out heat, time is not required. Okay. Now, what is the, suppose it is not there in the original question, but I am asking, what is the power? If they are asking for power of the engine, suppose it is done by an engine, what is the power of the engine? Power equal to work done by time, because power is what? Rate of work done. So, or heat by time. In this case, it is heat by time. So, power equal to what? What is the heat? 4.8 into 10 raised to 6 divided by time is what? 3600. So, what is power? 4.8 into 10 raised to 6 divided by 3.6 into 10 raised to 3. So, what is that? 48 by 36. If you divide by 12, what happens? It is 4 by 3. 10 raised to 3. That is, what is 4 by 3? 1.333 into 10 raised to 3 watt. Or power is what? 1.33 kilowatt. Kilowatt. Any doubt? Any doubt? So please check your answer. Please check your answer. Okay, 1.33 into 10 raised to 3. Next, an electric iron of 20 ohm takes 1 ampere current. Takes 1 ampere current. What is the heat generated? What is the heat generated in 1 minute? H equal to what is the formula? I squared RT. What is the current? It is resistance is 20 ohm. Current is 1 ampere. And time is what? 1 minute. That is equal to what? 60 seconds. So what is the answer? H equal to 1 into 1 into resistance is what? Sorry. 1 into 1 into resistance is what? 20 into time is what? 60. So what is the heat? One into 20 into 60. Current is 1 ampere. So 1 into 1 into resistance is 20. Time is 60. Why 60? Because it is 1 minute. 20 into 60 is what? 1200 joule. Or the same answer can be represented as 1.2 kilojoule. I hope it is clear. So let's do the next problem. What is the highest and lowest total resistance we can get from the resistances 4 ohm, 8 ohm, 12 ohm and 24 ohm. So what is the highest resistance we can get from these resistors and the lowest? Highest resistance means what? Highest resistance means what? Series combination. What is the answer? 4 ohm plus 8 ohm plus 12 ohm plus 24. So what will be the answer? 8 plus 4, 12. 12 plus 12, 24 plus 24 is what? 48 ohm. Now what is the lowest resistance value? Lowest resistance value means what? This should be connected in parallel. Lowest resistance, what combination? Parallel combination. Parallel combination. So R equivalent is equal to 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. So 1 by 4 plus 1 by 8 is what? 32. 8 plus 4. Here 12 into 24. 12 into 24 is what? 288, right? So 24 plus 12. So 12 by 32. Here 36 by 288. So I'm using calculator. Not much time left for me. So 12 into 24. Okay. So 12 by 32. 12 by 32 is what? When you divide it by 4, 3 by 8, then 36 and 288. 288 by 36 is 36 by 288 is 1 by 8. So what is answer? 4 by 8. 4 by 8 is what? 1 by 2. So here, remember equivalent resistance parallel combination formula 1 by R is equal to. So 1 by R equal to 1 by 2. So what will be the R? 2 ohm. 1 by R equal to 1 by 2. So R equal to 2 ohm. Any doubt? Clear, right? So we are understanding that. Always remember, in parallel combination, the equivalent resistance will be lower than the lowest resistance value. What is the lowest resistance value here? 4 ohm. So equivalent resistance should be lower than the lowest resistance value. So R equal to 2 ohm. I hope it is clear. Next question. Why electrical appliances are connected in parallel? Why electrical appliances are connected in parallel? See, in household circuits, we use parallel connection. Reason, in parallel connection, voltage will be same. But individual appliance will have different current. Appliance may have or can have different current. That is about parallel combination. One advantage. Second advantage, even if one device fails, others will work. That is another advantage of parallel combination. See, for example, when you connect 2 bulbs in maybe 3 bulbs in series combination, what is the problem? If one bulb fails, then it is equivalent to an open circuit. Then it is equivalent to an open circuit. So when one bulb fails, electricity can't pass to the other side. So this is phase, this is neutral. So what happens? There is a gap or circuit is not complete. So will there be any current flow? No. Next, now what is advantage? This is the problem of series combination. This is what happens in series combination. In parallel combination, what is advantage? This is one bulb, another bulb, another bulb or another device. See, each are having, suppose this is phase, this is neutral, each are having common potential, but current will be different based on the resistance value. So even if one bulb fails, the others will work because there is still separate path. So even if one device fails, other device will work. That is the advantage of parallel combination. So what we prefer in our appliances in household purpose, we prefer what combination? Parallel combination. We does not prefer series combination. Even if one device fails it, others will work. In series combination, if one device does not work, others also won't work. Others also won't work. That is a problem with the series combination. Continuing, our next question. And next question. An electric motor takes 5 ampere from 220 volt line. Determine the power of motor. Determine the power of motor and energy consumed in 2 hours. Current is what? 5 ampere. Potential is what? 220 volt. So what is the power? Voltage into current. So what is the power? 220 into 5. So what is the answer? 1100 watt, or you can say 1.1 kilowatt. I hope that is done. Now what is energy consumed? Now power equal to, remember, power equal to work done by time. Energy consumed is equal to work done. Energy consumed is what? Work done. Work done is equal to what? Power into time. So what is the power? So energy consumed equal to work done, that is equal to power into time. What is power? 1.1 kilowatt. So 1.1 kilowatt into time is what? 2 hour. Time is what? 2 hour. Energy consumed in 2 hours they are asking. So what is time? 7200 seconds. But in order to get the answer in kilowatt hour, there is no need to convert hours into seconds. So 1.1 kilowatt into 2 hours is what? 2.2 kilowatt hour. This is the energy consumed. So why I'm not converting to seconds? Because energy answer should be in kilowatt hour. So how to get kilowatt hour? Energy in kilowatt into time. Time in hours. So energy in kilowatt is what? 1 kilowatt. Into time is what? 2 hours. So answer is what? 2.2 kilowatt hour. So done. Next, a piece of wire having resistance R is cut into 5 equal parts. 5 equal parts. 5 equal parts. Then these parts are connected in parallel. Then these parts are connected in parallel. Then these parts are connected in parallel. The equivalent resistance of this parallel combination, the equivalent resistance of this parallel combination is R dash. Combination is R dash. Then find ratio. Then find ratio R by R dash. R by R dash. See, a piece of wire having resistance R. So original resistance is what? R, which is equal to rho L by A. Now it is cut into 5 equal parts. So what is the new resistance? R dash. Resistivity does not change. When you cut, what happens? Length becomes L by 5. And there is no change in cross-sectional area. So that is equal to what? Rho L by 5A. Rho L by 5A. The equivalent resistance of this parallel combination. This is the resistance of one resistor. Listen, after cutting, the original wire is having this much length. We are cutting into 5 pieces. Each piece resistance is what? Rho L by 5A. What is rho L by A? R. So one parallel combination is what? I am writing R1. R1 stands for first parallel combination. R1 equal to rho L by 5 by A. So R1 equal to what? R1 equal to R by 5. Why R by 5? Because if you cut a wire length by, it is cut into 5 equal parts. So one part length will be what? 1 by 5 of original length. When you cut a wire, no change in cross-sectional area. So what is the one resistor, one piece resistor, rho L by 5 by rho L by 5A. What is rho L by A? Original resistance R. So what is the one piece resistance? R by 5. Now how many pieces are there? R by 5, R by 5, R by 5, R by 5, R by 5. All these pieces are connected in parallel. So what is the R1? Take one resistor divided by R dash is what? Take one resistor divided by number of resistors. What is one resistor? R by 5 divided by number of resistors is what? 5. So R by 25 is the equivalent resistance, that is R dash of this parallel combination. Now what we have to find out? R by R dash. Original resistance is R divided by R by 25. So what happens? R gone, 25 goes to the numerator. So what is answer? 25. What is answer? 25. I hope you got the answer correctly. So how it is done? R equal to rho L by A. When you cut that, what happens? Length becomes 1 by 5. So what is one piece resistance? R by 5. How many such pieces are there? 5 pieces. Resistor values are same when they are connected in parallel. Take one resistor divided by number of resistors. So R by 25. So what is the ratio? R by R dash, that is 25. I hope it is clear. Next year. An electric bulb is rated 220 volt and 100 watt. 220 volt and 100 watt. When it is operated on 110 volt, when it is operated on 110 volt, 110 volt, comma, the power consumed will be what? The power consumed. See, electric bulb is rated at 220 volt. So voltage is what? 220 and the power is 100 watt. Now remember, the same bulb is operated on 110 volt. What will be the power? Remember, in these type of problems, you have to remember the quantity which remains constant is resistance. For a device, voltage might vary, current might vary, but what is the quantity that remains constant? Resistance. So what is the resistance formula? Resistance power voltage formula, power equal to V square by R. So R equal to what? V square by P. So R is equal to what is V square? 220 into 220 divided by power is what? 100. So 0, 0, gone. So 444, I'm sorry, 484, 22 square 484 divided by 484 ohm is the resistance. That is the resistance. Now the same bulb is connected to what? First case, this is the bulb. This was the potential 220 volt. What was the power rating? 100 watt. Now same bulb is connected to what? Same bulb is connected to, operated on 110 volt. 110 volt. Now resistance, once you find out the resistance of the bulb, it remains fixed. Whatever be the voltage variation, current variation, resistance will be the same. So we have to find out power and we have to choose a relation which contains voltage and resistance. So we have three options for power. One formula V square by R, other formula VI, and other formula I squared R. So which formula is having voltage and resistance? The first formula. So V square by R we are choosing. So power is equal to 110 into 110 by 484. So this formula we are using. So if you solve that, 110 into 110 divided by 484, if you solve that, you will get 25. So what is the answer? 25 watt is the answer. So we have three formula, but we have to choose a formula which contains voltage and resistance. Now this question is very important. In this type of problem, you have to understand it is the resistance that remains constant. Other quantities like voltage and current may vary, but resistance remains the same. So continue. A copper wire has diameter 0.5 millimeter and resistivity rho is equal to 1.6 into 10 raised to minus 8 ohm meter. 1.6 into 10 raised to minus 8 ohm meter. Remember, unit of resistivity ohm meter. What will be the length of wire? What will be the length of wire to make resistance 10 ohm? To make resistance 10 ohm. Now, what are the data given? Diameter is given 0.5 millimeter. So it has to be converted to meter. So 0.5 into 10 raised to minus 3 meter. Now, resistivity rho is what? 1.6 into 10 raised to minus 8. Length is question mark. With the resistance R equal to what? 10 ohm. So R equal to what is the formula? Rho L by A. So instead of, in terms of L equal to R into A by rho. R into A by rho. What is R? 10. What is A? Pi r square. Instead of r square, I should write pi into d by 2 the square, because radius is diameter half. What is the resistivity? 1.6 into 10 raised to minus 8. So answer is 10 into 3.14 into, what is D? 0.5 into 10 raised to minus 3 divided by 2 the whole square. Whole divided by 1.6 into 10 raised to minus 8. If you do this calculation, you will get the length value as 122.66 meter. 122.66 meter. If you do this calculation, you will get this answer. Okay. Okay. Now there is a sub question also. How much does the resistance change if diameter is doubled? How much does the resistance change? Does the resistance change if diameter is doubled? If diameter is doubled. If diameter is doubled. So what happens here? Here we are doubling the diameter. Now remember, resistance directly proportional to 1 by cross sectional area. A is equal to what? Pi r square, or you can write pi into d by 2 the square, isn't it? So resistance directly proportional to 1 by pi d square by 4, isn't it? Pi d square by 4. I hope it is clear. So resistance directly proportional to 4 by pi d square, where 4 is a constant, pi is a constant. So we can write r directly proportional to 1 by d square. When you write proportionally, you can remove the constant. So what happens? When diameter increases, what happens? Radius decreases. Okay. Now what happens? Here diameter is what? Doubled. Diameter is doubled means what? R d becomes 2. What happens? R directly proportional to 1 by 4. That is radius becomes 1 by 4. Radius becomes 1 by 4 original value. When diameter is doubled, radius becomes 1 by 4 its original value. I hope it is clear. So do remember the formula. R equal to rho L by A. L equal to RA by rho. RA by rho. Then what is radius? Diameter half. Millimeter has to be converted to meter because SI unit is meter. I hope it is clear. Next, when a 12-volt battery is connected across an unknown resistor, an unknown resistor, there is a current of 2.5 milliampere. There is a current of 2.5 milliampere. There is a current of 2.5 milliampere. Find value of resistor. Find the value of resistor. Voltage is what? 12 volt. Resistance value we don't know. Current is 2.5 milliampere. So how to convert it into ampere? 2.5 into 10 raised to minus 3 ampere. Find value of resistor. I equal to V equal to IR. R equal to V by I. So R equal to what is the V? 12. divided by current is what? 2.5 into 10 raised to minus 3. So 12 into 10 raised to 3 divided by 2.5 will be the answer. If you solve that, if you solve this value, you will get 4.8 into 10 raised to 3. 4.8 into 10 raised to 3 ohm or 4.8 kilo ohm. I hope it is clear. I hope it is clear. Direct question. Only thing is that milliampere should be converted to ampere. Next question. An electric heater of resistance 8 ohm, 8 ohm draws draws 15 ampere from the mains. From the mains means power supply. From the mains for 2 hours. Calculate rate at which heat is developed in the heater. Heat is developed in the heater. An electric heater of resistance R equal to 8 ohm draws a current I equal to 15 ampere from the mains for 2 hours. Time is what? 2 hours. Calculate the rate at which heat is generated. Rate of means what? Power we have to find out. What we have to find out? Power. I hope it is clear. Now what is power? Power is equal to work done by time. In electrical circuit, work done is equal to heat. So power equal to what? Heat by time. Power equal to heat by time. So power equal to what is the heat? I squared RT by time. So power equal to what? I squared R. So we don't have to go for time because time is cancelled in this equation. So what is power? What is the current value? 15 into 15 into resistance is what? 8. So 225 into 8 is the answer. What will be the answer? If you solve that, what will be the answer? 225 into 8, answer will be 1800 joule per second. Joule per second, or what is another unit? Watt. Why joule per second? Because power is work done by time. Work done unit is joule, time unit is second. You can use either joule per second or watt. I hope it is clear. There is no need of calculating time because time is not required, because in the equation while doing the problem, we have seen that time is cancelled. So that problem is also done. Next question, two lamps, one rated 100 watt 220 volt, 100 watt minus 210, it's not minus 220, 100 watt 220 volt, and other 60 watt 220 volt, 60 watt 220 volt are connected in parallel, to electric main supply. Why? What current is drawn from the line? What current is drawn from the line? Is drawn from the line if supply voltage is 220 volt. If supply voltage is 220 volt. Two lamps, one rated 100 watt 220 volt, other 60 watt 220 volt are connected in parallel to a electric supply. What current is drawn from the line? If supply voltage is 220, what is the supply voltage? 220 volt. Now the situation is like this. This is the first lamp, this is the second lamp. It is connected in parallel to a supply voltage of 220 volt. Supply voltage of 220 volt. Now, what is the first power rating? 100 watt. Second one, 60 watt. Now, voltage is same because it is a parallel combination. Connected in parallel to electrical main supply. What current is drawn from the line? See, first one is rated 100 watt 220 volt. Second is also 220 volt. So, first of all, we should find out the current through it. We know that power equal to voltage into current. So, what will be the current here in the first case? Current I equal to P by V. What is current? P is what? 100 by voltage is what? 220. So, 100 by 220 here, first case it will be 0.045 ampere. Let this be I1. Because let this be lamp 1, this is lamp 2. So, current through lamp 2 is I2, current through lamp 1 is I1. So, what is I1? I equal to P by V. So, I1 equal to power is 100 divided by 220. So, it is 0.45 ampere. In second case, what will be the power? Not power, power is given. What will be the current? I2. I2 current will be equal to what? Power by voltage. What is the power? 60 by 220. So, answer is 6 by 22, which is equal to 0.27 ampere. So, which one is having more current? Which one is having more current? The first one, right? 0.45 ampere. No. First one is taking more current. What we have to find out? What current is drawn from the line? So, I am understanding the current that flows from the line is I. That gets split into two, I1 and I2. So, what will be the original current? I is equal to I1 plus I2. So, original current I is equal to what is the I1 value? 0.45 plus what is I2 value? 0.27. So, what will be the original current? If you add that, your answer will be 0.72 ampere. So, which one draws more current? The first one, L1. Now, with this data, we can find out the resistance also. How to find out resistance? We know that power equal to V square by R. Actually, it is not R, but I am telling you, you can find out resistance also. R equal to what? V square by P. I hope it is clear. It is not required, but I am telling you in advance. Sometimes they will ask you for the resistance also, which is R equal to V square by P, and which resistance value remains the same. Always remember, resistor value does not change. Next question. Which uses more energy? A 250 watt TV set, a 250 watt TV set in 1 hour, or 1200 watt toaster in 10 minutes. Toaster in 10 minutes. In 10 minutes. Let's see. First case P1 is what? 250 watt. Time is what? 1 hour. Time is what? 1 hour. That is equal to what? 3600 seconds. Second case P2 is equal to what? 1200 watt, and T2 is equal to what? 10 minute. That is equal to 10 into 60, that is equal to 600 seconds. So these are the two cases, and we have to take which one uses more power, which uses more energy. Energy is equal to what is the formula? Power into time. Energy is equal to power into time. So first case, what is power? 250 into time is what? 3600. If you solve that, your answer will be 900 kilojoule or 900,000 joule. In the second case, energy is equal to power into time. So power is 1200 into time is 600. In the second case, it is 720,000. That is 720 kilojoule. So which one uses more power? The first case, right? 900 kilojoule. So TV set uses, which one uses more energy? TV set uses more energy. Always remember, energy equal to power into time. Energy is work done is equal to power into time. Power equal to work done by time. Always remember this formula. Power is equal to work done by time. Work done is equal to power into time. Done. So that is also done. Next, a battery of 9 volt is connected in series with resistors 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.4 ohm, 0.5 ohm, and 12 ohm. How much current flows through the 12 ohm? How much current flows through the 12 ohm? Flows through the 12 ohm. That is our question. So let's see what are the resistance values. 0.2 ohm, 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm, and 12 ohm. And 12 ohm. Sorry, what I have written. Battery supply voltage is what? 9 volt. Supply voltage is 9 volt. How much current flows through the 12 ohm? That is my question. That is our question. Current through 12 ohm is a question mark. So what is current? V equal to IR, I equal to V by R. Okay. So we have to find out the current. So since it is a series combination, current throughout all the resistors are same. So first of all, I should get the equivalent resistance. What is the equivalent resistance? 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So what is the equivalent resistance? 0.2 plus 0.3, 0.5, 0.4, 0.9, 0.9 plus 0.3 is what? 0.14. Sorry, 1.4 plus 12. So what is the answer? Equivalent resistance 13.4 ohm. What is equivalent resistance? 13.4 ohm. Now current I equal to what is the formula? V by R. V is what? 9 volt by resistance is what? 13.4 ohm. If you solve that, your answer will be 0.67 ampere. Answer will be what? 0.67 ampere. Now remember, this is the current through 12 ohm, 0.67 ampere. But you should remember the 0.67 ampere is the current which flows through all the resistors. Because what kind of a combination is this? Series combination. So in series combination, current will be same. I hope it is clear. Next question. How many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line. Carry 5 ampere. So I equal to V by R. How many 176 ohm connected in parallel? In parallel, what is equivalent resistance? How many 176 resistors? That means what? Resistor value is same. But we have to find out the number of resistors. When resistor value is same and when resistors are connected in parallel, what is equivalent resistance? R by N. And what is the current we are getting? 5 ampere. What is the supply voltage? 220. So I equal to V by R by N. So I equal to V into N by R. So N equal to I into R by V. So number of resistors 5 into resistance value 1. One resistance value is what? 176, right? 5 into 176 divided by 220. If you solve this, your answer will be 4. Your answer will be 4. If you solve this, your answer will be 4. N equal to 4. I hope it is clear. Next question. Several electric bulbs designed to be used on a 220 volt electric supply line are rated at 10 volt. Are rated at 10 watt. How many bulbs are connected in parallel with each other across 2 wires 220 volt line. If the maximum allowable current is 5 ampere, if the maximum allowable current is 5 ampere. Now let's see. Several electric bulbs designed to be used in 220 volt electric supply line. So what is the supply? 220 volt. What is supply? 220 volt. So V is equal to what? 220 volt. Power rating is what? 10 watt. How many bulbs are connected in parallel with each other across two wires in 220 volt line? The maximum allowable current is what? 5 ampere, and we have to find out what number of bulb that has to be connected. Now first of all, when you get this kind of problem, what value is fixed that we have discussed earlier? Resistance. So power equal to V square by R, resistance R is equal to, what is the formula? V square by P. Resistance R equal to what? V square by P. So what is the resistance of a bulb? Its voltage is 220 into 220, and what is the power? 10 watt, rated at 10 watt. So what is the resistance? If you solve that, the resistance value you will get is 4840 ohm. 4840 ohm is the total resistance. Now these bulbs are connected in what way? Parallel with each other. Bulbs are connected in what way? Parallel with each other. So you should understand that what will be the total resistance? One resistor value is what? One resistance value is got what? 4840. So equivalent resistance will be equal to what? 4840 divided by number of resistors. I hope that is clear. Now, that is the equivalent resistance is equal to what? 4840 divided by number of resistors. Now, we know that V equal to IR. What is V? 220. What is the current? What is current? 5 ampere into what is resistance? 4840 by N. So, what is N? 5 into 4840 divided by 220. If you solve that, you will get the answer as 110 bulb. What is answer? 110 bulb. Now again I am repeating, several electric bulbs designed to be used in a 220 volt electric supply. So what is the supply voltage? Supply voltage is what? 220. Are rated at a 10 watt. This bulb rating is what? 10 watt. How many bulbs are connected in parallel with each other? So these bulbs has to be connected in parallel with each other. How many bulbs we have to connect that we doesn't know. But it is connected across how much volt? 220 volt. We have to find out the maximum allowable. We have to find out how many bulbs need to be connected. What is the allowed current? 5 ampere. So how it is done? Voltage, power, current is given. Number we have to find out. First of all, we have to find out the resistance of the bulb which remains fixed throughout. So what is the resistance? R equal to V square by P, which is 4840. So one bulb resistance is what? 4840. Now these bulbs are connected in parallel. So what is the parallel combination formula? Take one resistor divided by number of resistors. That is the equivalent resistance. So if you substitute the equivalent resistance value, the current should be 5 ampere. So V equal to IR, the R value is 4850 by N, V is 220, current is 5. So if you solve it for N, you will get 110 bulb. I hope it is clear. I hope it is clear. Next question. Show how would you connect how would you connect three resistors? How would you connect three resistors? Each of resistance 6 ohm. Each of resistance 6 ohm. So that the combination has resistance of 9 ohm and 4 ohm. Resistance of 9 ohm and 4 ohm. So, what is the question? How would you connect three resistors, each of resistance 6 ohm? So, get a resistance of 9 ohm and 4 ohm. So, let me do this. Suppose first two 6 ohms connected in parallel. So, what is the resistance and the other 6 ohm in series? So, what happens here? 6 ohm parallel means what? Take one resistor divided by number of resistors is what? 6 by 2 is equal to 3 ohm. That is in series with the another 6 ohm. What will be the equivalent resistance? R1 plus R2. So, 3 plus 6, that is 9 ohm. Equivalent resistance is what? 9 ohm in the first case. I hope it is clear. Now, so, we got 9 ohm. Now, how to get it? How to get 4 ohm? That is our next question. How to get 4 ohm? Now, the method to get 4 ohm is like this. This is 6 ohm. This is what? Other two 6 ohm connected. So 6 ohm is there and this is what? 6 ohm and 6 ohm. So this is the method. So upper 6 ohm only, lower 2 are connected in series because there is only one path. So it becomes what? 12 ohm. Now 6 ohm and 12 ohm are in parallel. So what is the formula? R1 R2 divided by R1 plus R2. So R1 R2 is what? 6 into 12 divided by 6 plus 12. 6 into 12 is what? 72 by 18 is equal to 4 ohm. Now these two are in series. That series combination is in parallel with the 6 ohm. So I got the total resistance as 4 ohm. I hope it is clear. Next question. A hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B. Two resistance coils A and B. Each of 24 ohm resistance. Each of 24 ohm resistance. Which may be used separately or in series or parallel. Which may be used separately or in series or parallel. What are the currents in these three cases? What are the currents in these three cases? Let's see. A hot plate of an electric oven connected to a 220 volt line has two resistance coil A and B, each of 24 ohm resistance. YL, which may be used. It's not why, it is which may be used separately or in series or parallel. What are the currents in these three cases? Now, what is the supply voltage? 220 volt. Supply voltage is 220 volt. And each resistance A and resistance B, both are what? 24 ohm. Okay, that is the data. That is the data. When they use separately, when we use it separately, what happens? Current I equal to, what is the formula? V by RA, first case. So 220 by 24. What is 220 by 24? It is 9.16 ampere separately. Now, when they are connected in series means what? What is equivalent resistance? This is RA, this is RB. Total resistance will be what? 28. So I is equal to what? Not 28, 24 ohm is right. 48 divided by 1 is 24, other is also 24. Supply 220. Supply is what? 220, right? Ah, 220. Supply is 220. So 48 by 220. So when they are used in series, if you solve that, you will get the answer 4.58 ampere. Not 4 point. I equal to V by R. Sorry. I equal to V by R. So 220 divided by 48. I equal to V by R. So answer will be 4.58 ampere. 4.58 ampere. Because I equal to V by R and the total resistance is 48. Now, when they are connected in parallel means what? It will be like this. So what happens in parallel? What is supply voltage? 220 volt. Supply voltage is 220. This is 24. This is 24. So total resistance is what? Take one resistor divided by number of resistors. So 24 by 2 is equal to 12 ohm. So I equal to what? V by R. So 220 divided by 12. So I is equal to 18.32 ampere. 18.32 ampere. I hope it is clear. It's very simple. First we are using individual resistance separately. When we use it separately, both resistors are having 9.16 ampere because resistor value is same and the voltage is also same. So current through resistor means when they are used separately, both will have 9.16. When they are in series, 4.58, in parallel 18.32. Now remember, in which case current is maximum? Parallel. Because in parallel combination, resistance will be what? Minimum. I hope it is done. Next here, compare power used in 2 ohm resistor. Power used in 2 ohm resistor in each of the following circuit. In each of the following circuits. In each of the following circuits. First one, a 6 volt battery. A 6 volt battery in series with 1 ohm and 2 ohm resistor. 1 ohm and 2 ohm resistor. Second one, a 4 volt battery. A 4 volt battery in parallel with 12 ohm and 2 ohm. 12 ohm and 2 ohm. Compare the power used in 2 ohm resistor in each of the following. 6 volt battery connected in series with 1 ohm and 2 ohm. 1 ohm So this is 2 ohm. It is connected to what? 6 volt battery. So this is the first case. So power we have to find out. Power. So better to take what? Power equal to I squared R. So what is current? I equal to V by R. What is V? 6. What is the total resistance? 3. Because 1 and 2 ohm series. So add. 6 by 3 is what? 2. So what is the power across 2 ohm resistor? Power equal to I squared R. So I is what? 2 into 2 into 2. So and what is the answer? 8 watt. What is the answer? 8 watt. Because power across 2 ohm is what? 8 watt. Why? Because power is I squared R. What is the current? 2 ampere. Now, 2 ampere current is the current starting from the positive terminal. Since it is series combination, both 1 ohm and 2 ohm will get 2 ampere current because series combination current is same. Next, a 4 volt battery in parallel with the 12 and 2 ohm. 4 volt battery in parallel with the 12 ohm and 2 ohm. Volt. So I is equal to V by R. V is what? V is what? No, 4 volt battery. What we have to find out? Power. Now in this case we have to find out power. What is the better option? Since it is parallel combination, voltage is same. So power is equal to what is formula? V square by R is the easy option, right? V is what? 4 into 4 divided by resistance is what? 2. So what is the answer? Power is 8 watt only. The second case is also power is 8 watt. Why I am using this formula? Because V square by R. Because it is in parallel combination, voltage is same and voltage is directly available as 4 volt. So it is easy to use the second case. Means this formula. Power equal to V square by R formula is the easy one. So thank you. We have done all the problems.